Let us create a new stage to run the code coverage and also see how to catch errors if we get any within the pipeline build. So to do that, we'll go back to our Jenkins file. In the Jenkins file, we'll create a new stage. So let me just copy the unit testing stage over here. And I would like to modify this by removing the retry option. I also remove the JUnit option. So let me rename this as code coverage. We will still need the with credentials binding step because it requires the credentials to do the or connect to the MongoDB and do the code coverage. So the command will change. It is npm run coverage. Okay. So let us quickly save this. Let's commit it. So a new pipeline should be triggered, pipeline number 17. I'll pause the video till this gets completed. So if you can see here, the pipeline build has been completed, which resulted in a failure in the code coverage stage. So let's check the logs. So in the logs, you can see that this has failed because it is not meeting the global threshold of 90% as we discussed earlier. So the coverage is currently at 79%. Okay. So this is the case where we can ignore the errors. So I'm just taking this as an example, catch the error and continue processing the next stages. Because as of now, if there are any other stages after code coverage, those stages will be skipped because there is an error in code coverage. So how do you catch this error? Change the status of the build and continue processing, the next stages. So to do that, you can make use of a step called as catch error. Okay, so how does the stage work? So I can, click on this help. So it says that, if the body throws an exception, we can mark the build as failure, but nonetheless continue to execute the pipeline from the statement following the catch error step. Okay, so this can be used for a wide range of exceptions and examples. I'm just using this for a very simple, code coverage example. So how do we define this? So you basically define a message. So I'm just going to say, you can give any message. I'm just going to say, oops, it will be fixed in future releases. And then you have a couple of options, like what would be the build result on failure. So the default option is failure, but I want to change this to success. Okay. And what would be the stage result on error? I want to change this to unstable. Okay. Not failure, because still it's a simple code coverage thing. So I'm just going to say unstable. So I can also see the example over here. And let me just generate this. Okay, so this is the snippet which you have to use within your Jenkins file. Basically, it's a block. So the npm run coverage command should be wrapped within this catch error block. Okay, so let's go back. So within credentials, I'll just add this new one. So before I commit the changes, I also want to publish the HTML report which gets generated in the code coverage thing. So where does the report get stored? So if you remember, if I go back, so we have already, ran the code coverage once. So it should have generated the reports. So if I go back to the classic UI, and if I go to workspaces, so it creates a coverage folder. Within the coverage folder, it has the lcov reports. Within there, we have, the HTML. Okay. So this is the one which we want to make use. So what we'll do here is, so we have the index.html, right? So how do I refer this? So to refer this, so I need to go back to the Jenkins file. I have a publish HTML command already created here. So let me just copy that again and just reusing it. So I'll run this outside the step. Okay, so let me use word wrap. Okay, so now the reports. So what is the report file? So it's basically index.html. The report name would be code coverage HTML report. The report titles are just leave it empty. But what would be the directory? The report directory is coverage / lcow - result. I think only result. So let me just double check this. Okay, so let me just quickly check all the contents. I guess that should be fine. So let us quickly go ahead and save this, catch error, and publish HTML. So a new build should be triggered. I'll pause the video till this gets completed. Okay, so as you can see here, the code coverage stage has been completed, and now the stage output is marked as unstable. So earlier it was marked as failure, but now it is unstable. So if you see here npm run coverage, it still has the error message, but the next step has also been completed because now you're using a catch error. So it was able to also publish the HTML report. So where do you see the catch error message? So it's not visible in this UI. So you can go to the classic console output UI and you can just search for oops. So here you can see that whatever message which we provided in the catch error block, so that will be added here and it will continue processing the next steps or stages. So an HTML report is also generated, as you can see here. So it can be viewed in both the places, like in the classic UI, you simply have to click on the code coverage HTML report. It gives you the complete report. So we are just doing the coverage for app.js file. It gives you the statement, number of branches tested, functions, lines. In app.js, it's also going to show you at what point the coverage is missing for what lines, right? So everything is displayed as part of the HTML page. The same HTML page can also be viewed from the Blue Ocean UI. You can go to artifacts and you have the same code coverage HTML report, right? So that's all for now. Thank you. Now that we have completed a couple of stages in the Jenkins file, let's go ahead and do a bit of refactoring. So within our Jenkins file, if we observe the unit testing and the code coverage stages, both the stages use the same with credentials step in order to get the username and password from the Jenkins credentials and using it to connect to the MongoDB. So is there a way where we can reuse this configuration? Maybe it can also be used in the upcoming stages. So it can be done using environment variables. So in the environment variables, you can define a single environment variable and fetch the details using the credentials method or the function. But the thing is, this environment is going to create 3 different environment variables. So if you try to access the Bitbucket common creds, which is the name of the variable, it's going to contain a username and the password separated by a colon in the format of username : password, which might be useful in scenarios where you will be passing the basic authentication. Or if you want to access only the username and the password separately, you can access them using this additional variables which contains the username. So the username is available in Bitbucket _common _creds _usr, which contains the username, and _psw contains the password fields. So how do you access them? So you just define the environment variable over here, and you can just call $ and the environment variable name. So if you want the username, you can use $environment variable _usr or the psw. So let's try to do the same thing for our, Jenkins file as well. So in our Jenkins file, so I would like to remove this. Okay, so let me just copy this. Okay, so before I remove that, so let me just go up to environments. So here I want to define a new environment variable. So let me name this as Mongo underscore DB creds. Okay, credentials or creds. And the value is, I think we can use credentials. So this is how I can define it, I guess. So credentials, you need to open and close the parentheses. Within the single quotes, you need to, give the MongoDB credentials. So that's how you can refer it. And let me, quickly remove this. Remove that. I can remove this as well. Let's have the catch error. We'll remove this. Okay. So I removed both of them. So let me indent this properly. Okay. And in the unit test, I just want to echo a couple of variables to see how it works. So I'm just going to first echo the complete variable. So let me say the variable name. So I can just use echo $ and the name of the variable. Similarly, I can also echo the username and password. So it should be underscore USR and underscore ESW. Okay. So let me quickly do this. So I'll just say username, password, and this is nothing but colon separate. Okay, so let me just double check this. So it is underscore USR and underscore PSW, right? So let me quickly save this. I'll just say using global environment variable, right? Let me commit and push. So within the Jenkins file, within Jenkins, a new build will be triggered. Let me pause the video till it gets completed. Okay, so as you can see here, the pipeline has completed and resulted in a failure. So in the unit testing stage, it ran for a couple of times because we have retry as 2. So let's go ahead and see this echo command or what is printed here. So in the first echo, which is the colon separated environment variable, it just gives you * because it also contains the password field, which is sensitive value. So it just gives you the masked value. You can see the username printed with underscore USR variable. And for underscore PSW variable, again, it is going to, give you the masked value. So this just proves that, you can, define them at the environment level, at the global level, and it will be accessible to all the stages within the Jenkins file. But again, the NPM test will fail because it expects the username password in a different variable name, which is Mongo underscore username and Mongo underscore password. So how do we do that? So in that scenario, we can't use this approach because in this approach, username and password are tied in the same credentials. So we need to have a separate text for both of them. So to do that, we can go to Jenkins, we can go to credentials. In the credentials, let's create a new credential. This is going to be a kind secret text. The scope is global. The secret is super user. So first I'm going to give the username. So I'm just going to say username. So let's create one. Let me create one more for this password. The kind is secret text. Let me give the value over here. This is password, MongoDB password. Okay, so let me create them. So we have created two new credentials of type secret text. So how do I use this now? So let me just copy this. Let's go back to our Jenkins file. So in the environment variables, so let me just create Mongo underscore username, and the same thing, I'm just going to use it for password as well. Mongo underscore password. So I need to change this to password, and I need to close the single quotes. Right. So now these two variables will be accessible to all the steps within this Jenkins file. And these are the variables which are expected by the unit testing and the code coverage stages. So they will be, able to access those values. Okay. So I'll just, leave this as it is. I don't want to change anything. So we can commit the changes and check out the response of the Jenkins status. But before doing that, I want to refactor it a bit more. So if you see here, a couple of stages are using publish HTML, archiving the reports is in JUnit. So I want to, do this publishing and archiving as part of the post build stages, right? So how do we do that? So you can also have a post always or a post failed step at the end of your Jenkins file. So let's see how it can be done. So let's go to the pipeline syntax. So in the pipeline syntax, in the declarative directive generator, so we have a post stage, right? So here you have various different conditions. So you can, run this post stage always regardless of the build status. You can run this if the build status is unstable, not built, if the run is aborted, success, failure. So you have a lot of options. So I just want to, run the, archiving the reports and publishing HTML reports in the post always stage. So let me just copy this, and we can, give this at the end. So let me go back. So I think we can define this over here. Post always stage. And let me just do a quick word wrap. Copy the publish, add it here. Similarly, I can get the JUnit. And where else do I have this? In dependency, yes, we have just clean the subject. Okay, and what else do we have? I think these are the only reporters we have, the archiving of, the JUnit reports and publishing the code coverage and the dependency check reports, right? So they go within the always stage. So let me quickly save this using post always and secret text. Let's commit them. Go to the pipeline. A new pipeline should be triggered. I'll pause the video till this gets completed. Okay, so as you can see here, all the stages have been completed. The unit testing stage has been successfully completed now. So now it was able to fetch the credentials from the Jenkins credentials secret text files and use them as environment variables. So it was able to connect to the MongoDB and do the test cases. And the same is also true for the code coverage stage. But here you notice something different. So after the code coverage stage has been completed, so the archiving of JUnit reports and publishing of the HTML reports has happened because we have defined this as part of the post always stage. You can also check them out. So if I go to the classic UI, let's go to console output, and we can quickly scroll down. So here, if you see, this is post action. So within the post action, it's going to, do the archival of the JNet reports and publishing of the HTML reports. So this is how we can make use of the post always step, and also the environment level or global environment level variables, which can be accessed by all the stages, and even the credentials can be defined in a couple of different ways. So based on your requirement, you can choose either of them. So that's all for now. Thank you. So let's dive into static application security testing, also known as static analysis. So what is static analysis? It is the testing method that examines your application source code to identify security vulnerabilities. You can imagine it as a code scanner that flags potential security issues. We will be using SonarQube, an open source platform from Sonar Source, for our static analysis. SonarQube helps you continuously monitor your code quality and perform automated code reviews. So what are the benefits of this static analysis? So it's going to help you to identify bugs early in the development lifecycle, saving time and money on fixes. Static analysis helps pinpoint areas in your code that might need restructuring or simplification. And it can also define project-specific coding rules and enforce them automatically, promoting consistent coding practices. So simply seeing the code is not enough. To address the issues flagged by SonarQube, we need to leverage the data it provides. And one of the options is pinpointing security issues. SonarQube scans your entire code base, highlighting specific lines where it detects security vulnerabilities. It also offers insights on how to address these vulnerabilities, empowering you to fix them effectively. And it also provides quality gates, which acts as your project security checkpoint, ensuring standards are met. You can define thresholds for various metrics within SonarQube, which also includes code smells, which are indicators of potential problematic coding practices. There are security hotspots, which are areas in the code exposed to security vulnerabilities. And finally, it also provides code coverage, which is the percentage of your code base tested by automated tests. So if any of this quality gate components or conditions fail, your entire build fails. This ensures that only code meeting your quality standards progresses through the development pipeline. Thank you. In this session, we are going to do static analysis security testing using SonarQube. I have already set up SonarQube on my virtual machine. So this is running on port number 9000. And as you can see here, I don't have any projects for the time being. If I go to quality gates, I do have a Dasher quality gate, which is going to have certain conditions. And the condition which we will be using is condition on overall code. It's going to check for coverage, and if it is less than 90%, it's going to, fail the project. Okay. And I want to set this as the default one. So let's go ahead and create a project. So I'm going to create a project manually, or if you want, you can also create a project if you're using, either of this in your project. So let's go create manually. So let me name this as Solar System project. I'll just go and say that the main branch name of my repository is main. And it's going to ask like, how do I want to integrate it? So again, it gives you all the famous CIs over here. So I'm again going to do it locally. You can also go with Jenkins, but let's just do it locally. So it's going to generate a token, which will be, used to connecting with this project and uploading the data, doing the analysis. So let me just say no expiration, but ideally speaking, choose a small expiration date. So let's say generate. So a token will be generated for this project. So this is used for identifying when your analysis is performed. So let's continue and let's choose the project. So our project type is Node.js. So Node.js is basically a JavaScript based project. So I'll just choose others for JS. And this is for Linux operating system. So I'm running this within a Linux OS. And that's it. So it's going to, give you this command, which can be executed in your Jenkins or on your Linux machine. So now let me create a stage and, execute this command. So for doing that, let's go back to our Jenkins file. So let me copy one of the stages. I'm going to do this after the code coverage. So I would like to name this as SAST SonarQube. I don't want to have any options over here. And for SH, I'm just going to do triple single quotes because I'm going to use a multi-line command. So let me get this from here. So we just copy pasted the command over here. So let's try to understand what the command does. First, let me indent it properly. So it is using a CLI called as Sonar Scanner, and it has 4 different arguments. So the first argument is the Sonar project key. So basically the Sonar Scanner, it's going to analyze the project based on the source path. So currently it is going to analyze all the files in the root directory. If you want to limit this to specific files, you can just mention the name of the file which you need to analyze. In my case, we just want to analyze the app.js. And once the analysis is completed, the Sonar Scanner, it's going to connect with SonarQube using the Sonar URL, which is provided here. It's going to log in using this token, which we have given here in plain text. In the next session, we'll also secure this using credentials. And once it logs in, it's going to upload the analysis to the project using the project key, which is provided up here. So that's how the command is used for doing the analysis and also uploading the result back to SonarQube. But if you notice one thing, so it requires the Sonar Scanner CLI. And if you remember, we don't have this installed either in the virtual machine where the agent or the controller is running, and neither in the Jenkins tools. So let us go ahead and install this within Jenkins. So in Jenkins, we can go to plugins. So within plugins, we can search for SonarQube Scanner. So this is the plugin which we will be installing. So you have various other options as well, but we'll just go with the SonarQube Scanner and we'll restart Jenkins after it gets installed. So let's give it a few seconds. So I just paused the video till the plugin got installed and Jenkins got restarted. So if you see the installed plugins directory, so we should be having the SonarQube Scanner for Jenkins installed and also enabled. So the next step is we need to enable the tool, right? So let's go to Manage Jenkins, Tools. So let's scroll down. So we have this Sonar Scanner for MS build installations, and we also have the SonarQube, scanner installation. So let's go with the scanner installations. So let's give it a unique name. So we will be naming this as SonarQube-scanner, and we'll also, append the version which we are installing. So I would like to install version 6.1.0. So I'll just use 610 in the name. And we are installing this from Maven Central. Okay. So let me just apply the changes. So once you have configured the SonarQube scanner, the next step is to configure this within the Jenkins file. So in the Jenkins file, so let me just copy a syntax. So let's go back to the Jenkins file. So in the Jenkins file, in order to use the CLI, I'm going to create a new environment variable. So the name of the environment variable is sonar_scanner_home, and I'm giving it the value as tool. And in single quotes, I'm giving the name of the tool installation which I provided in the Manage Jenkins Tools webpage. So sometimes, even after defining the tool over here, Jenkins might not be able to pick up the CLI path. So to avoid any issues, you can create an environment variable. In this way, you can define a key and a value where it's going to give you the path of this tool. So after you define this, so instead of simply using Sonar Scanner, you can also prepend the path as well. So for the path, I can simply copy the environment variable $SonarScanner/bin/sonar-scanner. So we can also echo the path just for demo purpose. So I can also add another step over here to just echo or print the path. So let me just remove the $sign. So it's going to echo the path, and it's going to make use of that path and run the Sonar Scanner CLI. So let's save this and check out the pipeline. I'm going to commit the changes. So the changes are committed. Let's go back. I think I need to log in again. So a new build is triggered. So I'll pause the video till this gets completed. Okay, so if you see, the pipeline has completed and the SonarQube stage is also completed and marked as successful. So if you see here, first we can check out the Sonar Scanner home path. So we are just printing out the path. So this is available within the Jenkins home directory tools, and this is the path. So it's making use of the path, and it's going to do the analysis. Okay, so you can check out all the logs over here. And once the analysis is successful, it also uploads. If you see here, it's uploading the analysis to SonarQube, and you can find the result at this specific endpoint, which is nothing but the SonarQube endpoint. Okay, so it also says that execution is successful, and the total time it took is around 16 seconds. So if I go back to SonarQube dashboard, so if you refresh the page, so this is what you come to. So this is the solar system project, and it gives you the overall code status, the new code status. Currently, if you see, it found 2 security hotspots, 3 code smells, and 15 minutes of depth. And if you see, the coverage is 0%. Ideally speaking, we should be getting some percentage in the coverage, but we are not getting it. So we'll try to analyze this in a minute. And something else, if you see here, since the coverage is 0 and it's not, passing the threshold value, which is less than 90%, so the quality gate status is failed. So let us try to fix this issue. The first issue is SonarQube is not able to, get the code coverage. So if I go back to the CLI, to the Jenkins pipeline, so before static analysis, we have the code coverage step, which is, generating the code coverage of around 79% for app.js file. But this is not getting reflected in SonarQube. So the reason is we have to explicitly pass an argument in order to capture the code coverage. And it can be done in different ways. So since we are working with the Node.js based application, so if you go to SonarQube documentation, so there is a section where you can add the coverage analysis parameter. And that is nothing but sonar.javascript.lcov.reports path. And this is the path. So if you can also, verify this. So we have this path available in the workspace. It is creating this file. So I'll just copy this. Let's go and check this out in the workspace. So let's go to workspace. let's go to coverage. In coverage, we have this lcov.info file. You can also view the file. It has some data over here, which might not be understandable for us, but it can be analyzed by SonarQube. Okay, so let's define this. So where do I paste this Sonar JavaScript lcov reports path? So again, I need to go back to my Jenkins file, and it can be added as an argument. But you need to make sure that you add -d sonar.javascript.lcov.reports path and the path of the file. Okay, so let me save this. So I'll just add. Okay, so let me quickly commit and push the changes. Let's go back. A new pipeline should be triggered. Yes, build number 22 has been triggered. So I'll just pause the video till it completes the SonarQube stage. Okay, so if you see here, the Jenkins pipeline has completed now. I had a few hiccups, so I had to manually run the build again. But if you see, the SonarQube stage has been completed, and it has also uploaded the analysis back to SonarQube. So if I go to SonarQube dashboard, and if I refresh the page, the code coverage should be updated. So when I refresh it, if I go to overall code, I should be seeing the coverage value being updated from 0 to 73. So this is because now it is referring to the coverage report available in that specific path. So we have solved one issue. So now SonarQube is able to, access the coverage, percentage, but even this coverage percentage is falling short of the 90% threshold. So the quality gate status is failed. But if you notice, the quality gate status in SonarQube dashboard has failed, but it is not reflecting within the Jenkins pipeline. In the Jenkins pipeline, the SonarQube stage is being marked as successful. It's because SonarQube is able to upload the analysis making use of the SonarQube host URL and also the login token. But the SonarQube dashboard is not able to send back the quality gate status back to Jenkins so that the pipeline can decide if the build is successful or it has to be stopped. So in the next demo, we are going to fix this issue. We'll make sure that SonarQube is able to send back the quality gate status back to Jenkins so that it can decide on the status of the pipeline. So that's all for now. Thank you. In this session, we are going to configure the quality gate status to either continue or stop the Jenkins pipeline and also do a bit of refactoring. So in order to automatically interrupt your Jenkins pipeline in case of the quality gate failure, we will make use of the SonarQube extension or the plugin within Jenkins. So this extension poses a webhook URL, and the SonarQube can be configured to send the quality status back to Jenkins using this webhook. So the process is described in this image. So it has multiple steps. So step 1 is nothing but a triggering of the Jenkins pipeline. So whenever the Jenkins pipeline job starts, in the second step, the job is going to make use of Sonar Scanner to trigger the analysis of the application. In the third step, the Sonar Scanner is going to send the results to the SonarQube server. In the fourth step, the SonarQube server completes the analysis, computes the quality gate configured by the project, and checks if the project fails or passes the quality gate. And in step 5, the SonarQube server sends the pass or failure result back to the Jenkins webhook exposed by the SonarQube plugin within Jenkins. And in step 6, the pipeline job continues in case of pass or fails in case of the quality state failures. So that's how you can make use of webhooks and the quality gate status in either to continue or fail the pipeline. So as a first step, let's go ahead and configure the webhook within SonarQube. So before that, let me show you that Jenkins exposes a webhook URL. So you can open a new tab. So Jenkins listens on port 8080. So you can simply search or type a URI SonarQube-webhook, right? So if you see, this is the webhook endpoint, which is exposed by the SonarQube plugin within Jenkins, right? So you need to be sending a post request with this. So let me just copy this plugin. Let's go to SonarQube. So within SonarQube, let's go to administration, configure, webhook. So here, if you see, currently we don't have any webhook defined. So let's create a new one. So let me name this as Jenkins webhook. So I'll just give the endpoint over here. I don't want to use any secret, so I'll just go with these two options and create it. So a new webhook has been configured in SonarQube. So SonarQube will now send the quality gate status back to Jenkins. And in Jenkins, we'll do a couple of refactoring. So if you see the Jenkins file, so currently the Jenkins file is exposing the login token. So it's not a good practice. So let us try to, secure this. So to do that, we can go back to Jenkins. In Jenkins, we'll go to system. So within the system configuration in Jenkins, you can set up the SonarQube server details. So if you see here, we have the SonarQube server and we have the SonarQube installation. So let's add SonarQube. So let me give it a unique name. So I'm going to name this as SonarQube server. You need to give the endpoint over here. So this is the endpoint of SonarQube, which is running or listening on port 9000. And the token, you need to give a token over here, right? So let us create a new token. I think the token option is not available over here. You can't add credentials. So let me save this. So first, let me get the token. So I'm going to use the same token which we have used in the last session, or you can also generate your own token as well. So if you want to generate token, you have to go to SonarQube server. You can go to security, or I think you can go to my accounts, security, and you can generate new tokens as well. Okay, you can have it for different types and different expiry. Okay, so I'm going to use the token which we generated in the previous session. So let me go to credentials, create a new credential of type secret text. Let me paste the token here. So the ID is SonarQube token. So I'm just going to say SonarQube server token. So let me copy the ID. So let me refresh this page. So you should see a new option available here. So I don't want to go with the advanced settings, so I'll just save it. So after you define the SonarQube server details, so you can wrap the entire SonarQube stage using this installation option. So we can go to the snippet generator and let me refresh this. So let me search for with. So there is a with SonarQube environment step. So it's going to ask you for the token. I think the token is not required. You only need to, give the name of the server details which you just configured. Okay, so the credentials is not required. So let me just copy the entire thing. You can also double check this in the step reference. So I can just search for with SonarQube environment. So it requires the installation name, and the credential ID is optional because we already give it in the installation name, right? So we just give the name of the installation. So let me go back to my Jenkins file. So I want to wrap the complete command within here. So let me just add it over here. So I need to replace this. the credentials are not required. So you need to give SonarQube server. So this is nothing but the name of the installation, SonarQube server. Okay, so that is the option which I have gave here, and I need to close this as well. So, and since we have the host URL within the installation, I can remove the host URL over here. And we can also remove the token. So the token is also part of the environment or the installation. So you can remove the URL and the token part. Okay, so that's how you can refactor it so that the token is not exposed. So now for the second part, we have to make sure that this stage waits for the quality gate status. So how do we do that? So to do that, again, we can go back to the step reference, and here, we can search for something called as quality gate. So there is a step available when you install the SonarQube, plugin in Jenkins, which is wait for quality gate. So it's going to, wait for the SonarQube analysis to complete and return the quality gate status. So even this can be configured in your pipeline. So wait for quality gate, and you can abort the pipeline if the status of the quality gate is a failure. And you can also wrap this in a timeout so that, it won't wait indefinitely for the status. So we'll use both this option. So first, let me just copy this wait for quality gate. Let's go back to Jenkins file. And I want to add this after the step, wait for quality gate, and abort the pipeline if the quality gate status is failure. And I want to wrap the complete step in a timeout. Okay, I just want to make sure that it won't run this forever. Okay, so let's go back. So I can use the timeout directive. So what is this timeout directive? So let me just copy this. So I think it is, let me go back, sorry. So it's available in the declarative directive generator. And I'm sorry, it's in the snippet generator. So there is a timeout option. So the timeout option basically enforces time limit. So it's going to execute the code inside the block with a determined timeout limit. And if the time limit is reached, it's just going to raise an exception and abort the build process. Okay. So again, it can be in nanoseconds, microseconds, milliseconds, and up to days as well. So I'm just going to use a timeout of 60 seconds. Okay. So let me just copy this. So this is time is 60, unit is seconds. Let's go back. So I want to wrap this completely in timeout. So let's indent this properly. That's it. So this is what we wanted to do. So I've added a timeout. I've added the with SonarQube environment so that it can use the the login URL and the token, and it's also going to wait for the quality gate status as well. So let me save this, and I've added one more small change over here. So let me explain what I've added. So if I go back to the previous pipeline, if you see the OWASP dependency check stage is taking a lot of time to complete. It's taking more than 2 minutes. And the reason is, if you see the logs, it is trying to, raise an exception when it is initializing the YARN audit analyzer. So ideally speaking, we don't need this YARN audit analyzer because we are making use of the node or the NPM audit analyzer. So we can disable this so that these errors are, not populated. Right. So to disable the YARN audit analyzer, you just need to add a simple line to the dependency scanning. In dependency scanning, if I go to the OWASP dependency check, I just added new argument, disable YARN audit. Okay. So let me save this. Okay. So I'll just say wait for quality gate, and let me quickly commit and push the changes. So let's go back to the pipeline. A new pipeline should be triggered for us. Build number 26. So I'll pause the video till this gets completed. Okay, so if you see here, the pipeline has been completed. And if you see, the SonarQube stage is marked as failure. So let's try to see why it is marked as failure. So it has completed the SonarScan analysis, and it also uploaded the reports back to the SonarQube dashboard. And after that, if you see, it is failing in wait for SonarQube analysis. So here, it's going to give you a couple of logs. First, it's going to show it is in progress. Then it's going to, get the quality gate, and the quality gate is error. Since it is error, the pipeline is aborted. So you can also verify this in the dashboard as well. So if I go to projects, and if I go to the solar system project, if you see, the quality gate status has failed. So this was sent back to the Jenkins pipeline, and the Jenkins pipeline has aborted the build because of the quality gate failure. So you can also check the webhook details. So we configured a webhook. So let's go to administration, webhooks, and if you see, there is a delivery, right? And it was successful. It just happened a few minutes ago. You can also check the details of the delivery. So here, if you see here, this is the server URL. Let me scroll down. So this is for this specific project, solar system project, for the main branch, and quality gate, right? So the status of the quality gate is error, and it's also going to show you the conditions, like where it is failing, the status. Okay, so for most of the things, the status is okay, but for coverage, the status is error because the threshold is 90, but the value is 73. So it resulted in an error, and this is what was sent back to the Jenkins pipeline using this webhook. And the pipeline was able to, get the status and abort the build. So this is how you can make use of SonarQube and the quality gates to, either continue or stop building based on the quality gate status, right? So before we proceed with the next demos, so you need to make sure that the quality gate value has been modified. So ideally speaking, you need to increase your code coverage and fix the other issues within your project. So if you want to know about the other issues, you can simply go here. You can click on the coverage. It's going to show you like what are the lines which is missing the coverage, what are the code smells. If you click on the code smell, it's going to explain why this is a code smell, what is the severity. You can also understand like why this is an issue, right? So if you click on this, it's going to explain why this is an issue, and it also gives you a solution also which can be used, right? So that's how SonarQube helps you to identify the issues, and it also pinpoints like where the issue is occurring and gives you some suggestions on how to fix those issues. Okay, so yep. Ideally speaking, the developer has to fix this issues and make sure that quality gate status is passing. But since we are focusing on Jenkins and not on SonarQube, what we'll do here is we are just going to, modify the value to be less than 70% so that the quality gate status passes. Okay, so I'm just updating the value. So I can re-trigger this pipeline. So there is this, rerun option, or you can also just, restart only this specific stage as well. So let me just restart the stage for the time being. So if you see, only this specific stage is running. If you wanted to run the entire pipeline, you can, use the restart pipeline also. So let's give it a few seconds. Okay, so as you can see here, only the SonarQube stage has been executed, and this is also marked as successful. So here, if you see, the quality gate status was success and the quality gate is okay. Since it is okay, the pipeline was successfully completed. So let's check the SonarQube dashboard. So if I go to project, if I go to overall code, if you see, the quality gate status is passed. And since the status is passed, the pipeline is also passing because I modified the quality gate where the coverage is less than 70%, which is above the threshold. You can also check the webhook once again. So if I go to webhooks, so a new delivery has been made. And if I scroll down, you won't see any errors over here. So all the statuses are okay. Even the coverage status is also okay because now it is above the threshold. Okay. So this is how you can make use of SonarQube to do the static analysis security testing, and also make use of the quality gates to either fail the pipeline or pass the pipeline. That's all for now. Thank you. Go ahead and create a Docker image using the Jenkins pipeline. So back in my Jenkins file, after the SonarQube stage, I would like to add another stage. Let me quickly paste it. So the name of the stage is build Docker image, and it has a simple shell command, which is going to use the Docker CLI to build an image, and the tag or the name of the image would be Siddharth67, which is the username of my Docker Hub account. The name of the image would be Solar System, and the tag would be the git commit. So here I am making use of the environment variables. So to the Jenkins pipeline, a lot of environment variables are accessible, and one of the variable is the git commit. So this is accessible only in pipelines where we have the checkout stage. So in this Jenkins file or in this pipeline, the checkout stage happens implicitly. So this variable will be accessible to all the stages, right? So to access the variable, I'm just using a dollar and the name of the variable. And of course, it's going to build the image from a Docker file. And the Docker file is also part of the repository. So this is a very simple Docker file. So it has a base image of node 18 Alpine, setting up a work directory. I'm copying both the package.json and the package-log.json files to the work directory. I'm running an npm install, and I'm copying everything from the local directory to this work directory. I'm setting up some placeholder environment variables for the MongoDB variables. I'm exposing port 3000, and I'm using a command npm start to start the container or start the application once the container is up and running. Okay, and if you notice, I'm using a copy, which is going to copy everything. But to avoid copying certain files, I'm also making use of a .docker ignore file. It's like .gitignore file, and I've given the files and folders which should be excluded from the Docker build. Okay, so that's the simple explanation. And to have a look at all the environment variables which are accessible to this stage and all the stages in this pipeline, we can also add another step, or I'll just say print env, just to print all the environment variables which are accessible here. Okay, so let me quickly save this. Let's commit the changes. Okay, so let me go back to the pipeline. So a new pipeline should be triggered here. So let's give it some time. In the meantime, I also want to show you how you can know what environment variables are accessible. So if I go to the pipeline syntax, so here you also have the global variables reference. So it's going to give you a list of variables which can be used within your pipeline. So you have a lot of variables available. And for source code management specific variables such as git commit, so these are not automatically defined as environment variables, as I've discussed earlier, but you can use them when you're using the checkout step. Okay, so apart from this, you have the build tag, the build ID, which gives you the current build ID identical to the build number. Okay, you have the job display URL, tag name. A lot of things are available, so you can use them as and when required. You also have the branch name as well. Okay, so we will explore few of them and use few of them as we move forward. Let's go to pipeline. So the pipeline is in the code coverage state. So I'll just pause the video till this gets completed. Okay, so as you can see here, the pipeline build has been completed, and the build Docker image stage is also completed here. So let's see what is over here. So first let's check the print env command. So this is going to print all the environment variables accessible to this pipeline. So it has Jenkins Homes, Mongo URI. I mean, these are the environment variables which we defined in the Jenkins file. But apart from that, we have the user who triggered this, the build URL, Jenkins server cookie, node name, workspace, right? So we have a few other options like the build number, build ID, right? So workspace temp, right? A lot of variables are accessible. And if I check the build command, so here it's using docker build -t, and you can see it is also using the commit ID. So this would be the same commit ID, which you should be seeing in the Git repository as well. So let me just go to the Git repository. Let me refresh this. So if you see the latest commit ID is starting with 9dbc4bb, and this should match here. Okay, so it's using the latest commit ID. It's building the image, and the image is successfully built. So in the next session, we will do a round of vulnerability scanning for this Docker image and then push it to Docker Hub. Thank you. In the previous session, we created a Docker image. And before pushing that image to a container registry, let's do a round of vulnerability scanning using Trivy. So what is Trivy? Trivy is a security scanner. So Trivy has scanners that can look for security issues and targets where it can find those issues. So it can do security analysis on a different range of targets like container images, file system, Git repositories, Kubernetes manifest files, and others. And it can find issues related to OS packages, software dependencies, any known vulnerabilities like CVEs, infrastructure as code issues, software licenses, and few other options as well. Right? So it does a wide range of security analysis, and it has a very comprehensive documentation available. So I would request you to go through this documentation whenever you have any issues. So we will be using Trivy just to scan the container image. And at the same time, it's also going to scan the Node.js dependencies as well implicitly. Okay. So how does this work? Ideally speaking, you need to install this on the machine where you want to run Trivy commands, or it is also available as a Docker image as well. You can also use the container image if required. Okay. But we will be using the CLI. So I've already installed this. We'll be covering that in a minute. And then if you want to use this, again, based on the target, the commands differ. So we want to use this for the container image. So in the container image, the command is very simple. You need to use Trivy image, and you need to provide the Docker image or the container image, which you want to, run the scan for. And it has a lot of options, right? So please go through all the options when and where required. And once it does the scanning, it also generates some reports. And, you can also get the reports in different formats like JSON, HTML, JUnit XML reports, and others. So we'll do that as we move forward. So now let's, go ahead and create a stage for it. So before creating a stage for it, let me show you in the CLI that I have Trivy installed. So I'm currently using version 0.55.2. And you can also do a simple Trivy image -h. It's going to give you all the commands which are accessible, and you can just, go through them. Okay, so it is a very huge list of arguments which can be provided. So let's add a stage. So I want to add a stage after the Docker, image built stage. So let me quickly add it. So I've already copied the command, so I'll paste it and I'll try to explain it. So let me close this. So the name of the stage is Trivy Vulnerability Scanner, or you can also say scanning. And I have a single shell command where I'm running a couple of commands. So what are these commands? Okay. So the first command is going to run trivy image. I'm giving the name of the image which was built or created in the previous stage. And then I'm checking for vulnerabilities. So it's going to scan for vulnerabilities. So here I'm just going to, I want this trivy scanner to highlight only the low and medium level severity vulnerabilities. And if it finds any low and medium level vulnerabilities, I want to exit using exit code 0. It means that I don't want to raise any error if it finds any low and medium vulnerabilities. I just want to have a log of it. Okay, so that's how you can make use of the exit code. So if it is 0, this command, even if it finds vulnerabilities of this severity, it won't raise an error. And then I'm using the quiet argument so that it doesn't print much on the console. And it's going to generate the JSON report. So I'm using format JSON and I'm outputting this, using a file name. So this is going to be trivy image medium results.json. Similarly, I have another command where I'm scanning the same image, but I'm scanning for high and critical level severities. Okay. And if this command finds any high and critical level severities, high or critical level severities, I want to exit using exit code 1. So I want to raise an error if it finds any high and critical level severities. And similarly, I'm using quiet and a JSON format, report. The name of this report is trivy image critical results.json, right? So this is how, I'm running a couple of commands. It's going to scan for, low, medium, high critical severities. If it finds low and medium, it won't raise any error because of the exit code. If it finds any high and critical level severity, it is going to raise a error. Okay. So after this, it's going to generate the report in JSON format. But if you remember in Jenkins, we can, publish HTML reports and also archive JUnit reports. So let's see if Trivy supports those formats. So for that, you can again go back to the documentation. So in the documentation, let me scroll down and see if I have any options. So we have this reporting option. And if you see the formats it supports is table, JSON, Serif, template, and GitHub. So let's see what options we have in the template, because here I don't see HTML and the JUnit thing. So let's go to template. So in template, I think we can convert the JSON output to different templates. So let's see. Okay, let me just scroll down. So the templates are basically available at this path. So let me just go to this path and see what templates are available in my installation of Trivy. So let me just go here. Let me just search ls template. So I have the HTML template. If you see, I have around 5 different templates: GitLab code quality, HTML and JUnit templates are also available. So since the templates are available, so we'll try to convert the JSON file to this template. So how do we do that? So let's check the documentation. So in the documentation, if you see, there is a converting option at the bottom. So let's see how to convert. So to generate multiple reports, you can generate a JSON report first and convert it to other formats with the convert subcommand. So I think we need to just use Trivy convert. You need to give a format and output. And we can also use templates as well. Okay, so that's how you basically do the converting. So, I mean, everything is documented in detail over here. So I'll just copy the commands which I'll be using to convert them. So let's go back. So I want to convert this as a post action. I don't want to do this, in this main body. I want to do this after, the commands are run. So what I want to do here is, so within the same stage, I want to use a post always. So post always can be used at a global level or even at a stage level as well. So let me use this at this stage level. So let me copy it and let me paste it. So it's a very huge one. So let me try to explain you what I'm doing over here. So this is over here. I think I have to close this. Okay, so let me save this. So here I'm using 4 privy commands again. So let me enter this. So then in this 4 commands, if you see, I'm just converting, right? So I'm getting a JSON. I'll be getting 2 JSON outputs. One is trivy image medium results.json, and the other one is the critical results.json. So I'm converting this JSON files to HTML and XML. So if you say this is the HTML one and this is XML one, using the templates option. So I'm using trivy convert format template and giving the template which is available at my local machine where I've installed trivy. So the template is junit.tpl. It needs the output value, and it also needs to the input value, which is the JSON file. So the same thing, I'm doing it for the HTML TLP also. The reason why you see 4 converts, because for the medium results, I'm converting them to HTML and XML, the JUnit one. And the same thing, I'm doing it for the critical results JSON as well. So that's the reason you see 4 of them. Okay, so after generating the HTML and the JUnit reports, so we can do another step over here. So we just want to publish the HTML and the JUnit reports as well. So let's do them in a single go. So we have this over here. So I'll again paste the content over here. So we've already done this a couple of times. So I'm just pasting the content here. So let me go back. So I'm just copy pasted a couple of publish HTML commands over here. So let me do a word wrap and explain what I've done here. Right. So these are the 2 ones which I copied. So here I'm again using a publish HTML, which we have done earlier, where I am trying to publish the HTML of the trivy image critical results.html, which I'm generating above. Okay, similarly, I'm also going to, publish the trivy image medium-results.html. And the name of the report, I'm just using trivy image, critical or medium, vulnerability report. Okay, the rest of the things remain same. So it's going to pick up this files from the root directory of this workspace. And this is similar to what we have seen in the other publish HTML commands. So similarly, I think we can also do a quick copy paste of the JUnit as well. So let me quickly do that. So we will be also, archiving the XML files. So let me quickly copy paste it here. And I think I can copy the same critical result set as well. Okay. So that's it. So let me save all these things. So we have done a lot of copy pasting here because we have done these steps multiple times earlier. So let me quickly, push these changes, and I'll quickly explain what we have done once again. So let me minimize the steps. Okay, so we added a new stage, trivy vulnerability scanner, where we are scanning the image which is generated in the previous stage using a couple of trivy image commands. In the first command, I'm checking for low, medium level vulnerabilities. If it finds any vulnerabilities of this severity, it won't raise any error because I'm using an exit code 0. But it's going to generate a JSON report, which will be accessible for us to review it. Similarly, in the second command, we are checking the same image for high and critical level vulnerabilities. If it finds them, it's going to raise an error using exit code 1, and it's also going to generate a JSON report. And this JSON report, we are converting them to HTML and JUnit reports using the trivy convert command and using a template which is available out of the box. And at the end of the day, we are publishing the HTML reports and also the JUnit reports. So that's what we have done so far. So let's go and see if the pipeline got triggered. Okay, the pipeline got triggered. It is in the build Docker image stage, and now it is running the trivy vulnerability scanning. So let's check them out. So let's not wait for them. So you won't see any output in the console because I think I'm using the quiet option, right? So if I remove the quiet option, you might have seen few things. But yeah, if you see here, now the pipeline has completed and the Trivy vulnerability scanner resulted in an error. So let's see why it resulted in an error. Okay, so it also, did the conversion. So I think all these files should be available in our workspace, and it is also uploaded. So first things first, so let's go and, check the workspace. Let's see if these files are created. So I can go to workspace, and I should be able to see, Trivy image reports, right? So I think I have around 6 reports have been generated. So I can open the HTML page, and you won't be seeing the, CSS, because I think I restarted Jenkins. So when you restart Jenkins, the CSS will also be gone, because it uses the content security policy. So let me quickly enable that. But before that, let us go and see the tests. So in test, so now we should be seeing more tests have failed. So what are this? So now this also includes the Trivy, errors as well. So you're seeing the busy box, severities, which are high and medium, right? So let me scroll down. Does it have any critical? So it doesn't have any critical level vulnerabilities. So it only has high and, medium level vulnerabilities. Okay. So I think I want to show you the HTML page. So I have the Trivy, medium, and critical vulnerabilities, so as you can see here, the CSS is not there, but you can still read the report. So it only found high level vulnerabilities. Since they are high level vulnerabilities, it is failing the build. Okay. So let me go to medium vulnerability report. So they are medium and, low level vulnerabilities, but for this, it won't raise any error. It simply, generates a report. So I guess, we want to bypass this high level vulnerabilities. We only want to raise an error if there are any critical level vulnerabilities. So how do we do that? So for doing that, I guess we can simply modify the command a bit. So instead of, checking for both high and critical level, let's only check for critical level vulnerabilities. Okay. So for doing that, so let's go back. So here, in the Trivy command, I'll just remove the high over here, and I'll be using it here. So if there are any high level vulnerabilities also, it's going to ignore them. It won't raise an error. But if it finds any critical level vulnerabilities, it is going to raise an error now. Okay, so let me save this. But before I commit the changes, let me do one thing. So I want to enable CSS. So I'll just search for Jenkins content security policy. If you remember, we have done this earlier. So let me do this once again. We'll unset the header. Let me go back to Jenkins nodes. Let's go to script console, add this, run this. I think that should be good. So now let me quickly commit the changes. Commit and push. Okay. So it should trigger a new build. Let me close all this. So I'll just pause the video till it completes all the stages. Okay, so as we can see here, the Trivy stage is also successfully completed now. So if you see here, it won't give you any errors because for any low, medium, high, I don't want to raise an error. But I guess it did not find any critical level severities, so it didn't raise an error. So we can check this out again using the HTML reports. So if I open the critical report, so it does not have any vulnerabilities of critical level. So you don't see anything over here. So let me open the medium vulnerability report. And it finds a lot of medium level, high level, low, and I think even it should also show some high level vulnerabilities as well. So it also shows you where it is finding them within the Alpine, image or in the node packages as well. So that is in the image, and this is with respect to the Node.js packages. Okay, so it is running a scan on the Docker image as well as the Node.js dependencies as well, and it gives you a lot of details like the vulnerability ID, where it was fixed, what is the installed version currently, and some additional details using the links. Okay, So that's how you can, do a quick round of vulnerability scanning for the Docker image and also for the Node.js packages. And the same can also be used for, few other use cases as well, like Kubernetes manifest files or, checking the licenses or doing some benchmarking as well, which we are not going to cover, but Privy is capable of doing those as well. So in the next stage, we are going to publish this image to a container registry. Thank you. So far, we have built a Docker image, run a vulnerability scanning using Privy, and now we're going to push the image to a container registry. Well, let's go back to our Jenkins file. Let me copy one of the stages and create a new stage. So I'm going to name the stage as push Docker image. And the command would be relatively very simple. So it's going to be a Docker push and the image name. But this won't work because you also need to log in to Docker Hub. So I'm going to use Docker Hub as the container registry. So you need to log into Docker Hub in order to push the images. So where do you provide the credentials? So for that, we can make use of a different plugin. So back in Jenkins, so let me go to plugins. So we will be installing a Docker pipeline plugin. There is a Docker pipeline plugin. So it is capable of doing a lot of stuff. Okay, so there is a detailed documentation available, like how you can use this. So you can also check out the global variable reference. You have Docker, you have with registry, with server, image ID, building, but we'll just use this, for, making use of the credentials to publish the image. So you can just go through this documentation if you're interested to know what are the different capabilities of this plugin. So once the plugin is installed, I'm going to refresh the pipeline syntax. So you can go to global variable reference. You see there is Docker option over here. Okay. And it gives you all the different, options which you can use with this plugin. So we are interested with the with registry plugin, where you can give registry URL and along with the URL, you can also give the credentials for logging in. Okay. So to do that, let's go to snippet generator. So I can just search for with. It should be with Docker registry. Okay, so it is over here within the advanced and deprecated thing. With Docker registry, set up a Docker registry endpoint. So I can also, check the details over here if required. So by default, the registry URL would be pointing to index.docker.io/v1. If you want to use a different container registry, you have to give the endpoint over here. It could also be your private Docker registry as well. Okay. So apart from that, so I'll just use double quotes over here. You can also give the registry credentials. So let me add one quickly. So it's going to be of kind username with password. I'm providing my Docker Hub credentials, the username and the password. So the ID, I just want to use Docker Hub credentials. And for the description, I'll just say Docker Hub credentials. So let me just use the Docker Hub credentials, generate the pipeline, the pipeline script, and this is how it looks like. So let me just copy this with Docker registry. It has the credential ID and the URL as well. Let's go back. So we need to modify this a bit. This should be just double quotes. You don't need to wrap them in single quotes again. This is how you can wrap a command. So it's going to make use of this credentials and the default URL for connecting with, your Docker Hub registry and, pushing the image. So let's quickly push this. Let me commit and push. If I go back, a new pipeline should be triggered. So I'll pause the video till this gets completed. Okay, so as you can see here, the pipeline build has been completed. The Docker push image has also been completed here. So if you see the logs, it should be, referring to this specific repository, and the push is also successful. So if I go to my Docker Hub account, I'm already logged in to my account, and I already have this container image over here. So I've been using this for quite a long time. So if I refresh this, so you should see that the last pushed is 1 minute ago. So if I go here, I should be able to, see a tag which was pushed a minute ago. So the tag is starting with CF1715A. I think that should be the same, Git commit ID. Okay, the same thing we can also, check this in Git. So in Git, let me quickly refresh this page, and this is the latest commit ID, right? So with this, we have completed a very basic CI pipeline. So we have done the continuous integration. So we have done the dependency installation, done a round of dependency scanning. We did unit testing, code coverage, static analysis, security testing using SonarQube. We built a Docker image. We tested for vulnerabilities using Trivy, and then we pushed the image to Docker Hub. So now the next steps would be the deployment steps. So we are going to cover that from the next session. Thank you. So let's go ahead and understand the deployment approach. So this is the pipeline which we are working on, and within this, we have completed the continuous integration stages. So we have done all the stages. So the next one is about deployment. So we will be starting the deployment by connecting to AWS EC2 instance, and we will be deploying the Docker image and do the integration testing. So these two stages should only be run when we are working in the feature branch. So whenever there is a push to the feature branch, it should do the continuous integration stages and then deploy the application or the Docker image to the AWS EC2 virtual machine and do an integration testing. And once this is successful, the user will be raising a pull request. And when there is a pull request, it should be deploying the image or the application to Kubernetes using Argo CD. And after the Kubernetes deployment, we are going to do a round of dynamic application security testing using OWASP SAP. And the deployment to Kubernetes and this dynamic application security testing should only happen within the pull request or any changes which are done in the pull request. And once the pull request is merged to the main branch, then we are going to do a deployment to AWS Lambda, update the Lambda configurations, and then invoke the Lambda function or do a round of testing of the Lambda function, right? So this is the approach which we will be following. So any changes to the feature branch, we will be deploying the application to AWS EC2 instance. And whenever we raise a pull request, the application will be deployed to Kubernetes. And whenever we merge the pull request to main branch, we will be deploying the application to AWS Lambda. Thank you. From this session onwards, we will start the deployment part of the pipeline. And as part of deployment, I'm going to make use of a couple of different AWS services like the EC2 virtual machine, S3 bucket, and Lambda functions. So in this session, I want to quickly show you the different AWS configuration I have. And I'll also set up my Jenkins instance to use those AWS credentials and connect with this AWS services. So this is my AWS console where I am in the EC2 instance dashboard. So I have a single EC2 instance which with the name of dev deploy. This is currently in the running state, as you can see here. And I've also connected to this EC2 instance over here. And if I do a quick docker ps, I need to do a sudo docker ps. So this is a plain Ubuntu EC2 virtual machine which has Docker installed. And currently, if you see, it is already running a solar system image which was, I think, created 3 days ago. Okay, and this is the virtual machine where we will be deploying our image as part of the feature branch. Okay, so this is the EC2 instance, and I also will be using the same AWS instance for pushing few artifacts to S3 bucket and also deploying to Lambda, which I will cover in the later sessions. But for connecting with this AWS, services like S3 and Lambda, and also for EC2 instance, you need to have a user role and some credentials. So I have created a user. So let me go to IAM dashboard. I have a Jenkins user, and this user has some permissions. If you see, it has 3 policies. So I've just given the full access to Amazon EC2, Amazon S3, and AWS Lambda full access, right? So this user has access to all these 3 services. Okay. Ideally speaking, you need to have least privilege permissions, but since this is a demo, I'm just providing the full access for these 3 subservices. Okay. And when you do this, it's also going to, give you a set of credentials, which I already have. So this is the access key. And I also have the, the secret key as well. So these keys, you need to securely store them in your Jenkins. So let's first, save these keys. Okay. So within Jenkins, how do I store these keys? So you can make use of plugin. So let's go to Jenkins. So first, let us go ahead, install a plugin. So the name of the plugin is AWS Step. So you have a lot of AWS plugins. So if I just search for AWS, you see we have a ton of AWS plugins for different services. You can just explore them and use the one which is most suited for your requirement. So our case, I'm just going to use the AWS Steps plugin, which is pipeline.steps. So let me install this. Okay. So it's going to install a lot of different services over here or plugins. So let me quickly restart Jenkins after this. So I'll just do a quick Google search. I just want to show you the documentation of this plugin. So this pipeline AWS Step plugin, provides you different options to interact with the AWS API. You can interact with the S3 bucket. You can do deploy API, SNS publish, list AWS accounts. You can also work with ECR. You can work with ELBs, Elastic Load Balancers. And I think you can do much more with this. So this is a complete documentation on how you can, use this plugin. So I guess it should already be installed and restarted. So let me go back. The plugin is installed. So the next step is how do I create credentials for this? So for creating credentials, so you can go to manage Jenkins, credentials. Let's go to global, add credentials. And in the kind, now we should be having something called as AWS credential. So this is available because we just installed the plugin. So in the AWS credentials, you can mention an ID. So for the ID part, since this credentials will be used for, interacting with EC2, S3, and Lambda, I'm going to name all of them in the ID part. So I'm just going to name AWS S3 -EC2 Lambda -cred. Okay. And for the description part, I'm just going to say AWS credentials. So for the access ID, let me just copy the access ID. I'll remove the extra space. Let me also copy the secret. Okay. So if these are valid, so let me just say advanced. Okay, I don't want to create anything advanced. So let's say N. Okay, so let's create it. So, okay, let me go back. So you can also verify if the credentials are valid or not. So let's go back. So here, if you see, you should be seeing a message saying these credentials are valid and have access to 6 availability zones. This means that whatever credentials which are provided are valid and you can use them. Okay. So this is how you can, create a credentials, and you can use this in the upcoming sessions. Okay. And apart from this, we also need to connect with this EC2 instance. So for connecting with this EC2 instance, we will be making use of the, the private key. Okay. So I do have a private key available. So how do I connect with this EC2 instance with the private key using SSH? So for doing that, we have to install another plugin. So let me go back to plugins. I will be searching for a plugin called as SSH agent. So this plugin basically allows you to provide SSH credentials to builds via the SSH agent in Jenkins. So let me quickly install this. So after installing this, we will be creating another credentials to hold the private key of the EC2 instance. So let me go back to manage Jenkins. Let me go back to credentials and create a new credential over here. So this is going to be of type certificate, or I'll just use SSH username with private key. The ID, I'm going to name this as AWS. Okay, I think I need to name this a bit differently. So let me name this as AWS dev deploy EC2 instance. The description, I'm just going to say this is SSH username and private key for EC2. The username is Ubuntu, and I want to enter the private key directly over here. Okay, and it does not have any password, so I'll just create it. Right, so we created a couple of credentials here. We installed the AWS step pipeline plugin, and then we configured the AWS credentials, and we also installed an SSH agent plugin and also configured an EC2 instance private key using, the SSH username with private key credential type. So in the next session, we will create a stage to connect with the EC2 instance and deploy the Docker image. That's all for now. Thank you. Let's go ahead and deploy the application to AWS EC2 instance. To do that, after the push Docker image stage, I would like to add another stage. So let me copy this stage and modify it. So let me try to minimize this. Okay, so I just want to remove the with Docker registry and even the shell command. So the name of the stage would be deploy AWS EC2. And here we will start with deploying it to EC2 instance using SSH. So if you want to use SSH, you need to make use of the SSH agent. So we already installed the SSH agent plugin in the previous session. We also set up credentials to hold the private key. So let's generate a snippet for it. So I can just search for SSH. So we should be having an SSH agent step, and it requires a credential. So it is selecting the only credential which we have, which is SSH username and private key for EC2, and the username is Ubuntu. So let's generate it. So this is the snippet which we have to use. So let me just copy this, go back, paste it. So let me close this. Okay, so within this SSH agent step, you need to use your SSH command. So I'll just use shell script. I'll just open a shell. And here, let me copy the command which I want to use. So I'm using SSH -o, and I am also using something called as a strict host key checking as no. So this command basically presses the pop-ups which asks you questions which may prevent the command from executing. So I'm just saying that, this should not be happening. And then I provided the username and the IP address of my EC2 instance. So in this example, I am hard coding the IP address of my EC2 instance. So you don't need to hard code this. To make this scalable, you can also dynamically retrieve the EC2 instance IP address, which we will be doing in the next stage. But for the time being, we'll just hard code this. And after this, this command basically connects with your EC2 instance. It's going to take the private key available in this credential and connect with it. So after connecting with it, you need to run the commands. So I'm just opening a double quote and I'm running a if condition. Within the if condition, I'm checking, if there is any container already running with the name as Solar System. If it is running, we need to stop this first and then, remove it and then deploy the Docker image. So I'm just using another command, docker stop Solar System and docker remove Solar System. So once this is removed, then I want to, run the docker command. So let me also copy and paste the command for running the Docker image. So this is the command. So the command is sudo docker run. I'm giving the name of the container as Solar System. And I'm also passing the Mongo variables such as the URI, username, and password, which I have available within the environment variables at the global level in this Jenkins file. Okay. And I'm exposing the posts on 3000 and I'm just giving the image name. So this has to be closed, close this. Okay. So this is how, you can SSH to your EC2 instance and you can, run some commands to, deploy your Docker image. And before we commit this, we need to do one more thing. So if you see here, I'm using some if-else loop over here or a if loop. So this if loop is not possible within this declarative pipeline. So this is part of the scripted pipeline. So if you try to commit this and run this, the pipeline will fail because it does not understand this if loop. So how do we include certain, commands of the Groovy scripting within the declarative pipeline? It can be done with the help of the script step. So the script step basically takes a block of the scripted pipeline and executes that in the declarative pipeline. Okay. So if you say this example, so this is a declarative pipeline, in which, we have a step which is doing a for loop. So if you want to do this for loop, it has to be, within the script block. Okay. So we'll do the same thing in our example as well. So in our example, so I want to, use the script block for the entire, shell command. So after the step, I'm just going to use script. Let me open a tag and I think I'll just indent this completely and close it. Okay, so this is how I think, did I make any mistakes? Script, yes. So we added a script. Within the script, we have the SSH agent plugin, which holds the private key. Then it's going to connect with the EC2 instance. It's going to check if a container is running. If it is running, it's going to stop and delete it. And then it's going to, run the Docker image. So that's it. We can commit the changes. And to make sure that this step or this stage only runs on the feature branch, so we can add one more when condition over here. So to write a when condition, so I'll show you how to write when conditions. So I can go to declarative generator, and here I have an option of when condition. So this when condition, right, only when the when condition is satisfied, it's going to, run this stage or trigger the stage. So you can have multiple different when conditions. So you have different options like when all of the conditions in the nested when loop, get satisfied, then to execute the stage. You can do any of change log, not, tag, triggered by, and you can also use branch as well. So when you use branch, it's going to execute the stage if the current branch, matches a pattern. So in my case, I want to, run the couple of stages like the AWS stages only if it is on the feature branch. So I'm just going to say any branch which is starting with the name feature, and it could be any name. Okay. So this is how you can, create a when loop or a, when condition as well. Okay. So let's copy this, and this has to be given at the stage level. Okay. So you can have multiple conditions. I'm just going with a single condition. So this is the complete AWS deploy stage. So let's quickly deploy this. Okay. So this should be triggering a new pipeline. Let's go back. Let's go to branches. If you see, okay, there is a mistake, I guess. So let's check this out. It is expecting unexpected token at line 189. Okay, that's something new. So let's go and check it out. So I think I didn't close certain lines. So let me just check all the, braces. Okay, I guess. So I'm just closing this double quote over here. And then I have this SSH agent over here. I have the script, the step, EC2 instance. I think I have an extra. Yes, I think I have an extra one. So I think I can remove this. And I'll just move this around. I had an extra braces, I guess. Well, I guess this works. We just removed an extra braces. So let me just save all the commits. Let's go back. Let's see, a new pipeline should be triggered here any second. I think even that failed. Oh no, a new pipeline got triggered. So this is running. So I guess there are no more typos. Okay, so I'll pause the video till it gets completed. Okay, as you can see here, all the stages have been completed. The AWS EC2 deploy is also successfully completed. Let's check out the logs. So here, if you see here, the SSH was successful. It got connected to our EC2 instance, and it found a container with Solar System name, and it stopped the container. The name of the container is Solar System, and it was unable to find the new image locally. So it's going to pull the image from my Docker Hub. And once it pulls the image, it created the image as well. And if you see, this is the, the container ID, yeah, CAB88. So let's check this in the EC2 instance. So this is the EC2 instance. I'm already connected to this. So let's do a quick sudo docker ps. So yes, there is a container ID CAB88. It started about a minute ago, and it also exposed on port 3000. So let's try to access this on the public IP address. So let me copy this. So let's do a quick 3000. Yes, so our application is accessible in the AWS EC2 instance. You also see it's giving us the container ID as the pod name or the host name. It basically gives you the Docker container ID or the Kubernetes pod name. And it should also be, live. So I can do a quick live, right? So the application is accessible. So that's how, we can, deploy applications to AWS EC2 using Jenkins pipeline. Okay. So in the next session, we're going to do a round of integration testing. That's all for now. Thank you. In the previous demo, we deployed our Docker image to AWS EC2 instance. And in this session, we'll do a round of integration testing. So to do integration testing from the Jenkins pipeline, we need to know the public IP address of the EC2 instance or the public DNS name. But I don't want to hard code them. So if you remember, within the deploy AWS EC2 thing, we were hard coding the IP address. But I don't want to hard code it now. I want to fetch it dynamically. So how do I do that? So for doing that, I will be relying on a shell script because I'll be running a lot of curl commands and do a lot of validations. So in my root directory within my Git repository, I'll create a new file and I'll name this as integration testing ec2.sh. So I'm just going to name this as .sh and let me paste in the code. So I'll explain the code quickly. So this is a script which is going to first fetch the DNS name of the EC2 instance, and it's going to use it to run a set of curl commands. So in order to get the EC2 instance details, I'm going to make use of AWS CLI. I've already installed AWS CLI on my Jenkins controller node. So if I do AWS -- version, you can see that it's already installed and it's using version 2.17.56. Okay, so this shell script is going to make use of the AWS EC2 describe instance CLI. So if I go back to the documentation, so this describe instances is basically going to give you the data of all the instances which are there in your AWS account. Or if you want to have a specific instance details, you can also provide the name of the EC2 instance or the instance ID. And after you give it, let me scroll down and show you the example. So this is how the example looks like, or the response looks like. So this is reservations. Within reservations, it's going to give you the data of all the instances. And we are interested in the public DNS name or the public IP address. We want to fetch any one of them. Okay. So I'm using AWS EC2 describe instance. Whatever response it comes, I'm saving it in data and printing the data. And to get the URL, okay, so I'm running the same command. I'm using JQ to loop through the reservations and instances, within which I am checking the tag value. So I'm just checking it and evaluating it to dev deploy. So if it finds a tag of dev deploy, so that is the name of our virtual machine, if you remember, in EC2. So if I go to EC2, if you see, this is the name of my EC2 instance. Okay. So I'm just, checking that. And if it finds it, it's going to, get the public DNS name. And the public DNS name will be saved to the URL part. Okay, so I'm also printing out the URL. So once I get the URL, I'm running a FL loop. In the FL loop, if the URL is not accessible, it's just going to say could not fetch a URL and check or debug line 6, or it should be line 8. Okay, in my case. Okay. And then if I get the URL, if the URL is accessible, then I'm running bunch of curl commands. So the first curl command, I am just making a call to the URL on port 3000 and, hitting the live endpoint. And I'm just, storing the HTTP code to a variable. I'm creating the variable. And then I'm also, making a call to the same endpoint using post method. I'm trying to, fetch some data using a post method by passing some ID in the body, and I'm saving it to Planet Data. And from Planet Data response, I'm just, checking, what would be the name of the planet, which is, fetched in the previous call. And within this if loop, I'm having another if condition to check the status code is equal to 200 and the planet name is equal to Earth. And if it is true, it means that all the tests have passed. Else, it's going to exit with, exit code 1. So that is how I have defined the shell script. So the next thing is, how do I call this shell script? So for calling this shell script, so let me just create a new stage. So I would name the stage as integration testing AWS EC2. And here, I think I don't need with Docker registry. So I'll remove this. In SH, I'll just use single quotes, and I'm going to, use a bash command to execute the shell script. So it's going to be, let me just copy the path. Okay, I just need the name. So I'm just going to run bash integration EC2.sh file. But if you see here, in order to fetch the EC2 instance details using the describe instances command, the AWS CLI needs to be authenticated. It needs, the access key and the secret key ID. So how do I get that details? So those details, and you also need to pass the region also. So those details, we have already saved them as credentials in one of our earlier videos. So we'll try to reuse them. So let me go back to my Jenkins UI. So in the Jenkins, so if I go to manage Jenkins credentials, I have AWS. So I think I have this AWS S3 EC2 Lambda credential. So this credentials also have the permissions to fetch the EC2 data. Okay, so we'll make use of these credentials. So how do I make use of it? So we also installed AWS Pipeline Steps plugin. So that plugin creates or comes with a lot of steps. So here I can search for something called as with AWS. So it is going to help you to set the AWS settings for, nested code block. So here it's going to ask you for which region, you want to use. So I think my AWS is using US East 2 region. So I'll just copy that. So endpoint, I think it's going to make use of the AWS endpoint. If you're connecting to local stack or, any other AWS alternative, you can give the endpoint over here. So for credentials, you need to select the credentials. I think it's not displaying over here. So I'll select it at a later point. And I think the rest of the options, I don't need them for this use case, but it might be useful for some other use cases. So let me generate the script. So it's only giving me the region. Ideally speaking, it should also give me the credentials, but we'll add it manually. So let me copy this, go back, and I'll use this, before the code block or the shell block. So the region is US East 2, and I also need to add the credentials. So let me add credentials. And the credentials, let me copy the ID. So let me just check the spelling, credentials. So let me go back and let me copy this ID. That's it. So I guess these are the changes which we have to do. And one more changes, I think we want this stage to only run, for the feature branch. Okay. So let's add the when condition as well. Okay, so this is only going to be triggered if it is for the feature branch. So I'll also use a simple, I'll use one more command just to show you the environment variables. Sh print env, and I'm only interested in branch. Okay, I'm just going to grep for the branch. Okay. So let's save this. Let me commit this quickly. So we added a shell script and also modified the Jenkins file. So let's quickly push this. Let me just check if everything is fine. Let's go back to the Jenkins pipeline. A new pipeline is triggered, but it failed. Let me see. I think I forgot to close. Yes, I forgot to close this. So I opened it, but I didn't close this. Yes. So let me save this. Missing versus at 183, just for comment purpose. So let me commit this. Let's go back to the UI. I hope there are no more mistakes. It should trigger a new pipeline. So I'm just going to pause the video till this gets completed. Okay, as you can see here, the pipeline has completed. Even the integration testing stage was successfully completed. So let's check out the logs. So here, as you can see here, I just printed out the environment variables and I grabbed a branch. And as you can see here, the branch name is feature. So the when condition is going to work here. And if I open this shell script, so it's going to even, print the data. So first I'm making a call to AWS EC2 describe instance. So this is the complete JSON which I would receive. So from this JSON, I was using JQ and a couple of conditions to fetch the DNS URL or the private DNS or the DNS name. And then I was doing, 3 different curl commands to, get the status code, to get the planet data, and to fetch the planet name from the our response. And then I was testing them. So all the tests have passed. So the integration testing is successfully completed, right? So this is how you can deploy to EC2 instance and also do a quick round of integration testing by dynamically fetching the DNS name or the public URL of the EC2 instance by making use of the AWS CLI and also the AWS credentials. So that's all for now. Thank you. Let's have a brief overview about Kubernetes. Kubernetes is an open source container orchestration platform which was originally developed by Google and now is maintained by the CNCF. It is designed to automate the deployment, scaling, and management of containerized applications. The first major component of Kubernetes is a node. So nodes are the individual machines, physical or virtual, that make up a Kubernetes cluster. Nodes can be categorized either as worker nodes or controller nodes. Worker nodes run all the containers, while the controller nodes manage the overall cluster. The controller node includes the API server, controller manager, scheduler, and etcd. The API server is the entry point for managing the cluster and serves the Kubernetes API. A pod is the smallest deployable unit in Kubernetes. It represents a single instance of a running process in the cluster. Pods can contain one or more containers that share the same network namespace, storage, and IP address. They are often used to group containers that need to work together. In our example, we only have one container in a pod. If a pod experiences an issue, it is removed and it does not automatically restart. To prevent the need of manual intervention, we can utilize replication controllers or deployments which handles the task of pod recovery. So deployments are high-level abstraction for managing replica states and pods. They provide declarative updates to applications, allowing you to describe an application's desired state, and Kubernetes will handle the details of updating the actual state to match the desired state. So once the pods are up and running, how do we access them? So we can access them using services. So services in Kubernetes provide a stable and consistent network endpoint to access one or more pods. They can load balance traffic among multiple pods, allowing applications to be easily scaled without affecting external clients. Kubernetes offers several types of services to enable network communication between pods. So one of this type is load balancer service, which is used to expose your service to the external world, typically in a cloud environment. So it's going to create external load balance like AWS ELB or GCP load balance, which is going to route the traffic to your service. So it's important to note that the availability and the features of load balancer services may vary depending on the cloud provider or the on-premise infrastructure you're using. Additionally, using load balancer services may incur additional cost, particularly when considering that a distinct load balancer may be required for each individual pod or applications you wish to expose. So to avoid using multiple load balancers, one can make use of Ingress as an alternative solution. So Kubernetes Ingress is designed to manage and route HTTP and HTTPS traffic into the cluster. It provides more advanced and flexible traffic routing capabilities than a load balancer service. It is suitable for exposing multiple services under a single domain or for setting up more complex routing rules. You can route traffic based on path, domain names, and other HTTP request attributes. So when services are exposed through Ingress, they're often configured with a service type of cluster IP for several reasons. One major reason is cluster IP services provide internal access to the pods within the cluster but are not directly exposed externally. This allows you to have fine-grained control over which services are accessible within the cluster, ensuring that not every service is exposed by default. However, it's also important to note that the choice of service types and Ingress configuration depends on your specific use case and requirement. Thank you. What is GitOps? GitOps is a framework where the entire code delivery process is controlled via Git, which also includes infrastructure and application definition as code and automation to deploy changes and rollback. GitOps can be considered as an extension of infrastructure as code that uses Git as the version control system. Developers commit to a shared repository using a version control system such as Git. Usually, a feature branch is created, which is a copy of the main code base, where a team of developers can work on a new feature until it is completed. A continuous integration service automatically builds and runs unit tests on the new code and merges the code into a central repository. Before merging, the changes are reviewed and approved by the concerned team. A continuous deployment is the final stage in the pipeline that refers to the automatic releasing of any developer changes from the repository to the clusters. The core idea here is to have the infrastructure, applications, and all related components declaratively defined in one or more Git repositories. In the GitOps scenario, an automated process ensures that the desired state in the repository and the actual state in the production environment always matches. A GitOps operator runs within one of the Kubernetes cluster. It continuously monitors and pulls changes from Git repository and applies them within the cluster it is running. And it can also apply them in a different cluster as well. Meanwhile, if a developer merges new code to the application Git repo, an automated CI process kicks in and does a round of unit testing, builds the application, creates a Docker image, and pushes it to the container repository. And finally, it also updates the Kubernetes manifest within another Git repository. The Git operator identifies the difference between the desired state in the Git repo versus the actual state in the cluster. It pulls the changes and makes sure that the desired state always matches the actual state. GitOps also eases the rollback process. Since all the code is version controlled in Git, a team member can issue a simple git revert command to go undo any changes which are made earlier. Since the repo is continuously monitored by a GitOps operator, it picks up the changes and rolls back to the previous state. Thank you. Before we talk about Argo CD architecture, let's have a look at Argo CD concept and terminology. To understand and use Argo CD, one should be familiar with the basics of Git, Docker, Kubernetes, CI/CD, and GitOps concept. In this slide, we will cover basic terminology specific to Argo CD. In Argo CD, we will be working and creating applications known as Argo CD application. An application is a custom resource definition which gets created when we install Argo CD. An application in Argo CD defines the source and destination for your Kubernetes resources. Similarly, we have an application source type which defines the tools which are used to build the application. It could be Helm, Customize, or others. An Argo CD project provides a logical grouping of applications which is useful when Argo CD is used by multiple teams. The desired state of an application manifest stored in a Git repository is known as target state. The current or the live status of the application resources like pod, secret, config maps deployed in the Kubernetes cluster is known as live state. When an Argo CD application is created, it tries to synchronize the desired state in Git to the live state in cluster. This is called as sync, and it reconciles the current cluster state with the target state in Git. An example of this could be, by applying changes to a Kubernetes cluster. A sync status lets us know whether or not the live state matches the target state. Is the deployed application the same as Git says it should be? And finally, a synchronize operation status let us know whether or not a sync succeeded. A refresh option compares the latest code in Git with the live state, figures out what is different, and can initiate an automated sync or ask the admin to sync manually. Argo CD also provides built-in health assessments or assessments for several standard Kubernetes resources. It provides an overall health application status as a whole. Let's see how CI/CD works with GitOps. In GitOps, we are going to make use of two Git repositories. The first repository is going to have the application code along with the application resources like configuration data, certificates, or any images which are used in the application. And then we have a second repository which is going to contain the Kubernetes manifest YAML specifications of the application. So the GitOps operator, in our case, the Argo CD operator, which is running within a Kubernetes cluster, it is going to pull manifest from this Git repository, which is holding the Kubernetes manifest. And it is going to, create or, deploy the required resources within the cluster. And let's say a developer has pushed some changes to the application code repository or did some, merges, and then you have, new files like a Docker file, Jenkins, and also some, new application code. So we can make use of a Jenkins pipeline and have a CI pipeline where we can, go through a series of unit testing, build the application, and build the Docker image, and then push it to a, container repository. Once the image is pushed to the container repository, how do we do the deployment? So for doing the deployment, we are going to first clone the configuration repository, or the repository where we have the Kubernetes manifest. And then within the pipeline itself, we are going to update the Kubernetes manifest. So we basically update the image or the image version which is there in the deployment YAML specification. Once we update the image version within the deployment YAML, we are going to push these changes to a feature branch. And once we push this to the feature branch, the next step would be like opening a pull request to the Kubernetes manifest repository in order to push the new deployment YAML specification. So once a PR is raised, so project manager or architect is going to check the pull request, and he or she is going to either decline or reject it, or they can also approve and merge the pull request. So once the pull request is merged from the feature branch to the master branch, so the newly made changes will be available in the main or the master branch. And again, any new changes on this Git repository, this Argo CD operator, it's going to pull the new changes and deploy the new changes, right? So this is how the Argo CD operator listens for any new changes on the Kubernetes manifest repository, pulls it, and applies them within the Kubernetes cluster. Let's assume like the new image has some issues. So how do you roll back? So what we can do is, Argo CD admin or an Argo CD developer can quickly check the application history using CLI or using a user interface, like commands like Argo CD app history, which gives the entire history, like how many revisions of the application was created. And then we can quickly roll back as well. So you can either use the UI, or within the CLI you can use Argo CD app rollback and the application name along with history ID. It's going to quickly roll back to the previously stable state. So this is how a CI/CD pipeline looks like in GitOps. And in the upcoming demos, we are going to see how to create the Jenkins file, which consists of all the stages. And then we are going to raise a pull request and make the changes in the Kubernetes manifest repository. And at the end, we'll see how Argo CD is going to pull these changes and apply them, or do a quick rollback as well. So that's all for now. Thank you. Let's go ahead and clone a manifest repository and also configure Argo CD. So this is the manifest repository which I will be using. So this is currently hosted in GitHub. It just has a single Kubernetes folder, which has both the deployment YAML and the service YAML. So let us quickly clone this into Git. Let me copy the endpoint. In Git, let me quickly migrate it using the GitHub option. I want to do this in the Dasher organization. Let me remove -git and migrate. Let's give it a second. So it is successfully migrated. It has both the deployment YAML and the service. But if you look at the deployment YAML, this also requires a secret with the name as MongoDB credits. But if you see, we don't have that secret. So let's go ahead, create a secret and upload it to Git. So for doing that, I would go to Kubernetes cluster. So my Kubernetes cluster is running on a cloud provider and it is accessible in this VM. So if I do kubectl get namespace, it has this namespaces. So you see, I also have the Solar System namespace created 2 days ago. I can also do a quick get nodes -o So K is an alias for kubectl. I'm just using a shortcut over here. So if you see, I have a couple of nodes, running Kubernetes version 1.29.9. Okay. So let me clear this. So let's go ahead and create a secret. So let me just copy the command. So the secret basically contains the MongoDB's URI, username, and password. So I'm using kubectl -n Solar System, create secret, this is of a generic secret type. The name of the secret is MongoDB creds, and I'm passing in the Mongo URI. This is the Mongo URI, and then I'm passing the Mongo username and the Mongo password. But I'm not creating the secret. I just want to, generate a YAML file, and then I'm saving it to, this particular file. So let me create it, and let's do a quick read. So this is the secret created, and if you see, the values are base64 encoded. So now this has to be copied into Git. But there is a catch. So whatever files which we upload to Git repositories, so those are publicly accessible or accessible to anyone who has access to that repository. So it's never a good idea, and it's never recommended to upload sensitive files like secrets, even if it is a Kubernetes secret, because these values are just base64 encoded. If you decode them, you will get back the original value. So it's never a good idea to, upload the secrets. But we want to follow the GitOps approach, right? In GitOps approach, the Git repositories are the source of truth, and everything has to be there in the Git repositories. So how do we use this secret in the Git repositories? So what we can do is we can encrypt this using various tools. And today we will be using Bitnami secret for encrypting this secret. So I already have Bitnami secret running. So let me just get the pods within the kube system namespace. And if I scroll, you see I have a Bitnami sealed secrets pod running. So I'm going to make use of this pod and, create encrypted secret. So I can also do kubectl get secret. And within the secrets, I have a sealed secret as well. Okay. So the process is a bit different. So I think I've already covered this in the Argo CD course, but let me quickly cover this. So we need to first get the TLS certificate of sealed secrets. So I'm just going to do kubectl kube system get secret. So, okay. So from this secret, we need to fetch let me just copy the name of the secret. I want to get the JSON output. And from the JSON output, I'll just copy a command. So I'm going to use JQ. So I'm using JQ to, get the TLS certificate, decode it using base64-d and save it to a file. So let me check this. So this is the decoded TLS certificate of the Bitnami sealed secret. So after you get this, so we can quickly use a kubectl. So I've also downloaded the kubectl CLI. So, okay, I think I don't have a version. Let me see if I can print a version. Yes, so I have a kubectl. If you see, the version is 0.27.1. So using kubectl, we can quickly create an encrypted secret. So let me just copy a command and execute it here. So the command is kubectl. I want to output the YAML. The scope is cluster wide. The certificate is the public cert, which we just converted, which we just got it from the sealed secrets. And we are giving it an input of the Mongo credentials Kubernetes secret YAML, which we created a couple of commands ago. And the output would be stored in this file, which would be the encrypted, sealed secret. So if I check this, so this is a sealed secret. Okay, so let me copy the entire YAML file. And this can be stored in a Git repository. Okay, so let's go back to the Git repository, add a new file. Let me name this file as secret.yaml. That's it. So this, if you see, the kind is sealed secret. The API version is Bitnami. And this is having an annotation of cluster wide true. The name is MongoDB creds, which is required by the deployment manifest file. It's going to be created in the Solar system namespace. And if you see, it has the encrypted data of Mongo password, URI, and username. Okay, so that's how we can create an encrypted secret, which can be securely stored in any Git repository. So let's commit it. And this is how it looks like. So our manifest repository is ready. So the next step is creating an Argo CD application for this. And Argo CD is also created in Kubernetes. It's running in Kubernetes. So if I do kubectl get namespace, if you see the first namespace is Argo CD, I can do Argo CD get all. So you see it has a lot of pods running, which has the Argo CD controller, the repo server, the Argo CD server, and various other services are also running. So the Argo CD server is available on this node port 31663. So I've already logged in here. So if you see, this is 31663. And if you see within this Argo CD UI, I'm already making use of it by managing the Bitnami sealed secret. So whatever sealed secret pods which we have seen in the kube system namespace are managed by Argo CD. It's making use of a Helm chart internally. Okay, so let's create an application for our Solar system application. So let's say plus app. I'm going to name this as Solar system Argo app. The project name would be default. I want to manually sync this, so I'm going to select manual. If the namespace does not exist, I want to auto create the namespace while syncing. And the repository URL. So this is your manifest repository URL, which we just imported and added a secret. So let's paste it here. The head would be, the revision would be the main branch. So it only has one main branch. The path is Kubernetes. Okay, so the folders, the manifest files are available within the Kubernetes path. So I'm just going to give path as Kubernetes. The cluster URL would be the default service. And I don't want to give any names. So I think I need to give the namespace. So the namespace would be Solar system. Okay. So that's how you can create an Argo CD application. Let me create this. So it, made a call to the Git repository, and it was able to fetch the service, deployment, and the sealed secret manifest files. But it did not synchronize because we have selected manual synchronization. So it did not synchronize yet. So it's waiting for our, manual input. But we will not synchronize this now. So we will try to update this, deployment file with the, latest Docker image, and then we'll try to, do the synchronization. Okay. So that's what I wanted to cover in this session. So we have imported the manifest repository, added a sealed secret, and we also configured Argo CD application for our Solar system app. So that's all for now. Thank you. Okay, so let's start the process of deploying the application to Kubernetes. So in this first step, we will be updating the image tag. So if you remember, in the last session, we imported a new manifest repository with the name Solar System GitOps Argo CD. And here we have a single folder Kubernetes where we have a deployment YAML file. And within this deployment YAML file, we need to be updating this image ID or this image, right? So whatever image which we are creating in the Jenkins pipeline, it has to be updated over here. So once this is updated, we will be going back to Argo CD. And within Argo CD, we have also created an Solar System Argo app, which is currently not synced. So it is going to pick up the updates and we will be manually syncing it. So currently, if you see, this is out of sync because none of these resources are created. We can also verify this. So if I go to my virtual machine, if I do a quick kubectl within the Solar system namespace, we don't have any resources because Argo CD is yet to sync them to our Kubernetes cluster. So to do that, we will be creating a new stage. So we'll be updating this image using the Jenkins pipeline. So to do that, we will be creating a new stage. So to just save some time, I have copy pasted a new stage. The name of the stage is K8's update image tag, and it has a lot of lines. So I'll just go through each and every line and explain how it works. So this stage should be triggered only for the PR branches. So whenever a pull request is switched, we will be, running the Kubernetes stages. So we'll be having a couple of Kubernetes stages, and both the stages will only trigger and run if it is on a pull request. It won't run on a feature branch or any other branches. Okay, so this condition makes sure that it only runs for the PR branch or the pull request branches. And then we have a step. So within the step, the first step is we need to clone the manifest repository. So I'm using a shell script using a git clone, and I'm cloning the main branch of the manifest repository from DT. So this is nothing but the Solar System GitOps Argo CD repository. So once you clone this, we need to update the deployment YAML within this repository. So it basically clones into a separate directory. So to move to the directory and make the changes, I'm using the dir step. So what is this and how to use this? So if I go back to the documentation, so within the Jenkins pipeline nodes and processes, so we have a couple of options over here. And one of the command or option is the dir command, which is basically used for changing the current directory, and any steps inside this dir block will use this directory as current. Okay, so you just need to give the path. So that's what I have done here. So I'm using the dir and I'm giving the path where I want to go. So within this repository, I am using the Kubernetes. Okay, so in this Kubernetes path, we do have the deployment YAML file. So let me expand this. So it has a couple of commands over here. So the first step is to replace the Docker, image tag. So I'm going to again do a git checkout main. It is going to be on the main branch itself, but just to make sure I'm using this command again. And I will be creating a new feature branch within this manifest repository. The name of this feature branch is going to be feature the build ID. And again, the build ID, I'm going to dynamically, replace this using this environment variable. So I'm using $build_ID. And then I'm using a sed command to substitute the value, which is starting with Siddharth67 with this image ID, which is having Siddharth67, which is my Docker Hub username / the container name : the image tag, which is nothing but the git commit. And it's going to, replace them, within the deployment.yaml file. Okay. So this should be the same image ID, which you're pushing in the earlier stage. Okay. So it should be the same one. So this is how the image tag will be replaced. And I'm also just, reading the deployment YAML using the cat command. Okay. So once we replace it, we need to also commit and push these changes to the feature branch. So I have, a bunch of git commands, which is going to do this. So all this can also go into a shell script, and you can simply use a bash and run the shell script, but it's up to you. You can do this in multiple ways. So for committing and pushing, so I'm using a git config to set up, user email ID. Then I'm using a git remote set URL. I'm setting up the origin, and in the origin, you need to, use a Gitty token in order to, push the changes. Okay. So again, it's going to be, setting up the same URL, which is the manifest repository URL. Then I'm using a simple git add. I'm going to use a git commit, and I'm going to push the feature branch, which I just created and made changes into this, right? So these are the steps which will be done in order to update the image and push the changes back to the feature branch. So before I commit this, you need to also configure the Git token, right? So how do you get the Git token? So to get the Git token, let's go back to Git. So I'm going to go to Profile and Settings. I'll go to Settings option in a new tab. In the Settings option, you can go to Security, or I think we have to go to Applications. So within the applications, we can generate new tokens. So basically, these tokens grant access to your accounts using the Git API. So let me name this as Jenkins token. And yeah, I'll just go with all public, private, and limited repositories and organization access. But we have to select a bunch of permissions. So we need to give it the permission to play around with repositories. So I'm just going to give read and write access to the repository. So let's generate a token. So a token is generated. So please make sure that you copy this token and save it somewhere so that we won't lose it. So this token will be deleted once you refresh the page. So we will be storing this token in Jenkins. So let's go to Jenkins. We'll go to credentials. In credentials, let's create a new one. The kind is going to be secret text. So let me paste in the token. So this is going to be Git API token, the ID, and the description is nothing but Git API. So let's create this. So a new credential has been added. So let's refer this in the Jenkins file. Let's go to our Jenkins file. In the Jenkins file, we have to go to the environment variables. So let's quickly add Git token. And this is nothing but a credential. So let me just copy this. So this should be Git API token. So let me double check this value once. Yep, so it matches. So that's great. Let's go back here. So we have also referred the Git token. So this is the token which will be used here. So I'm using a variable $Git token. So it's going to fetch the token and it's going to use it for authentication purpose, right? So after doing this, we can commit the changes. But before committing, I would like to do one more step. The step here is, if you see this, step, we are cloning this manifest repository, and this pipeline will be executed multiple times. So if you want to execute this pipeline multiple times, each time it triggers, it's, going to clone the latest, repository or the latest changes from the main branch. But if a repository already exists on this workspace, it won't be able to clone it again. So you need to use git pull or git fetch. So you can either use a if condition or if else condition where you can, check if the, directory exists, then you can do a clone, else you can do a pull. But to simplify things, what I am going to do is I'm just going to add a script in post always, which is going to check if the repository is existing. If it exists, it's going to, remove or delete that specific folder. So let's go to post always. So I'm going to add this at the top. So let me just, okay. So here I'm using if condition. So since I'm using an if condition, it has to be within the script block. So I'm adding this in the script block. And within the if condition, I'm using something called as file exist. So what is this? So again, we can refer the documentation for this. So within the Jenkins pipeline basic steps, so you have a lot of steps which can be used within the Jenkins pipelines. So one of the steps which I made use is the file exist. So this is going to verify if a file exists in the workspace or not. So it's basically going to return true or false. Okay. So you can use this both in the declarative pipeline as well as in the scripted pipeline. in the declarative pipeline, you need to use that, within a script block. So I'm using this exactly as you see here. So if I go back, so I'm using this if file exists, I'm just giving it, this is the same directory, which we are cloning. So if the directory exists, I'm using a shell command to, just remove the directory. So this is going to run every time, and it's going to always do this. Okay, so these are the changes which I have done. So let me quickly commit the changes. So like commit and push. Let's go and see if a pipeline gets triggered. Yes, a new pipeline is triggered in the feature branch. So I'll just pause the video till this gets completed. Okay, so as you can see here, the build has been completed. And if you see, it got executed till the integration testing stage, but the Kubernetes update image tag stage was skipped. So why was this skipped? So it won't show you much of a logs over here. So we'll go to the classic, logs console. So let's go to classic. And if I go to the console output, let's scroll down to the bottom. So here, it's going to say that the stage gates update image tag was skipped due to the when condition. And it is expected. So if you remember, we have added a when condition. So this stage will only trigger if the branch is a pull request of type pull request. So since this was a feature branch, so it did not trigger anything over here. So let's go ahead and manually, raise a pull request. So let me go to, okay, let's go to dasher.org. Let me close the, let's go to Solar System. Okay, so a feature branch, the changes were pushed just a few minutes ago. So these are some checks which are automated. So if you click on this, it's going to, okay, let me go back. So if you see here, the build was unstable. So it's going to redirect you to the Jenkins pipeline stage, or the build, which was triggered for this specific commit. So these are provided out of the box. And if I go back, so, we made a lot of changes in the feature branch. So let's raise a pull request to the main branch. So I think we can make use of this. So we can create a new pull request. So this is going to raise a pull request from the feature enabling CI/CD branch to the main branch. And yes, it has a lot of commits and a lot of, changes. Okay. So let's create this new pull request. I'll just say added Jenkins pipeline and few other files. Okay, so let's create a pull request. Okay, so you can see that it has 33 commits and 4 files have been updated. So all those things will be available as part of the pull request. And if you scroll down, it's also going to have a couple of checks where it is going to check the head pipeline. And also it's going to, create a new pipeline. If you see for the PR, right? So if I go to Jenkins, so let me close this. So if I go to Jenkins, if you see a new pipeline got triggered, and if you see the branch is PR-1. So whenever a pull request gets created, it's also going to trigger, the pipeline within Jenkins. So this is happening because if you remember, we have a webhook which also sends, sends a request to Jenkins whenever there is a pull request as well. So let me show you that as well. So if I go to settings, webhooks, so if I go to this webhook settings, if you see, it is, one of the triggers option is pull request events. So for all the pull request events, it's going to trigger the pipeline. Okay. So if I go back to Jenkins, yes, it's going to run a pipeline. And since it is the first run for the PR branch, so you're going to see the run ID as 1 here. Okay, so if I go to branches, so in branches, it's only going to show you the feature / enabling CI/CD branch. If I go to pull request, it's going to show you the builds of the pull request. And I think this is also successfully completed. So let's go ahead and see what happened here. So you see a small difference over here. So it is going to run all the continuous integration stages, but it's going to skip the AWS stages. So if you remember, the AWS stages have a when condition, which only triggers if the pipeline got triggered on the feature branch or any branch which starts with the name feature. So these are skipped, but the Kubernetes stage got executed because this is on a PR branch or a pull request, has been triggered. So let's check the logs of the Skate's update image tag. So first, it's going to clone a repository. Then it's going to do a git checkout main. It's going to substitute the value, and it's going to show you the updated deployment.yaml file. So you can double check this. And then let me scroll down. It's going to set the origin URL. It's going to make use of the Kitty token, which we have added. It's going to commit the changes, and it's going to push the changes. So once the changes are pushed, so before the pipeline gets stopped, it also has if condition within the post always section, which is also going to remove the Solar System GitOps Argo CD manifest repository if it exists. So even this command has been successfully completed. So we can check this. So if you see here, it is created a new branch. The name of the branch is feature-1, which is the build ID. So if I go back to the repository, so if I go back to the manifest repository, if you see it got updated 2 minutes ago. And if I say branches, a new branch feature-1 has been created. And this was created, I guess, just 2 minutes ago. And if you see, the commit message is updated Docker image. And it has just updated the deployment YAML 2 minutes ago, as you can see here. And if I go here, you should be seeing an updated, image over here. Okay. So we have automated the process to, pull a Git repository, create a branch, update the image, and push the changes. So we have pushed the changes to the feature branch. So let's see if, the Argo CD has picked up anything. If I go to Argo CD, and if I try to do a refresh, you won't see any changes here. The reason is this Argo CD application is only listening on the main branch. It's not listening on any other branches. So if you see the details over here, and if you see the target revision, it is only concerned with the main branch. So let me zoom this a bit. So it's only concerned with the main branch. So now we have done changes in the feature branch. So these changes are not picked up by Argo CD. Ideally speaking, even here, you need to raise a pull request to merge the changes from feature 1 to the main branch. You can do that manually, but let's automate the pull request process as well using the Jenkins pipeline. And we'll see that in the next session. So that's all for now. Thank you. Let's go ahead and create a stage in Jenkins pipeline to raise a pull request in Gitty. So in Gitty, as I've mentioned, to manually raise a pull request, you can just click on this new pull request option, but we want to automate this using the Jenkins pipeline. So to do that, so Gitty exposes an REST API, and you can access the REST API in the Gitty UI. So in this UI, if you check the bottom right, so you have the licenses and also the API. So let's click on this API. So it's going to redirect you to Gitty API Swagger specification, and it has a lot of endpoints and services. And whatever you do in the UI can also be done using these REST APIs. So I'm interested to raise a pull request in a repository. So I can, open the repository option over here. And again, it has a lot of APIs of all different HTTP methods. So I'll quickly search for something called as pull. And even in pull, I think we have a lot of methods. So we are interested in creating a pull request. So if you see here, we have a post which is going to create a pull request. And again, when you expand this, it's going to help you to, make a call using the REST API. So it basically requires some information such as the owner of the repo. In my case, it should be the Dasher organization. So you can click on try it out. You can just enter some details, Dasher org. You can give the name of the repository. So in my case, it should be Solar System, GitOps, Argo CD. And then you also need to give a body. So body is the place where you need to give like who is creating this pull request, whom you want to assign this, what is the base branch to which you're pulling the request for. You can also add the head, which is from which branch you are raising the pull request, some title, labels, and milestones. Again, all these details can be provided here. You can edit the values and give some data over here. Okay. And once you give the data, you can also execute and try this out. So when I click on execute, if you see, it's going to give you a curl command. So this is of type post. It's going to have the endpoint. It's going to, have the headers and the payload, which, we just edited. But if you see the response, we are getting error not found 404. I guess I made a small typo somewhere. There should not be any space over here. So let me remove the space, click on execute. So now I'm getting 401 unauthorized. So if you see the message, it says that it requires a token. So where do we get a token? So we already generated a token in the previous session. So you can use that token for authentication because that token has the repository variable, or it has the repository permissions basically. So if you have the token, how do you pass the token? That is the next question. So again, this documentation helps you to understand how to pass the tokens as well. So if you see there is a lock icon over here, when you click on this, it's going to show you all the available authorization options. So you can pass the token in different ways in a header or a query parameter. So we'll just use this authorization header option. It says that the API tokens must be prepended with the token followed by space. So again, this is in the header. Okay. So you can just give token, and I'll just give some sample value for demo purpose. So you can click on authorized, close. Let's make a call. So if you see here, it's also going to append the authorization header because we just added the token. And still you should be getting 401 because I'm just using a random sample value token. So it says that user does not exist. But yes, this gives you a basic idea on how to get a REST API for, raising a pull request. So this is the curl command which we can use within the Jenkins pipeline. So how do we create a stage using this curl command? So let's go back to the Jenkins file. So in the Jenkins file, I have already, added a new stage. So the name of the stage is K8 raise PR. I've added this after the update image tag stage. So if I open this or expand this, so even this stage should be triggered only on the PR branches of the pull request, whenever there's a pull request. And if you see the steps, I have a single shell script, which is going to do a curl command. Okay, so this is the same curl command which we just saw in Gitty Swagger UI. So it's making a post call to the repository, and this is of /pulse. So I'm just hard coding the organization and the repository name. For the authorization header, I'm using token space the Git token, which we added as credentials and using this in the environments above. Okay, so if you remember, we added the Git token environment variable. Okay, and then in the body, so let me just get this body. Okay, so in the body, I'm just using the same user. I only have a single user in my Git account. So I'm just going to use git-admin, which is a username of the account as both the assignee and the assignees. And here, the head is nothing but the feature branch from where I want to raise a pull request. So feature-bind ID, and the base is the main branch. So you can give some body for the pull request and also some title. So this will be displayed in the pull request. Okay, so that's the curl command, and this is the stage which will help us raising a pull request using the Jenkins pipeline. So let me quickly commit these changes. Okay, so if I go back to my Git repository, so here I am within the Solar System repository. So if I refresh this, so whatever commits which we are doing to the feature/enabling CI/CD branch, so since we have already raised a pull request, so it will be added, to the pull request commit list. So if you see, we just committed it, and it's going to again trigger a pipeline for us. So if I go back to Jenkins, if you see a new pipeline, it got triggered, and the branch is PR itself, PR1. Okay, so let's go here. So it's going to take some time to get completed. So I'm just going to leave it. So in the meantime, let me just cover another concept. So here, if you come back to the pull request, if you see here, it is doing some checks. So basically, it is going to check if the pipeline status is successful or not. And it's going to, give you the details of the pipeline which got triggered whenever a commit is made over here. And as an admin, you can directly check the details of the pipeline by clicking on it. It's going to take you to that pipeline build. Okay. And if you want to enforce any rules where you want to only merge after, successful Jenkins build, you can also create those rules as well. So to do that, you can go to settings. In settings, you can go to branches. You can create a branch protection. So currently I don't have any branch protections. So I can add a new rule. You can give the name of the branch. So basically it should be the main branch, which, should be protected. And if I scroll down, you can disable pushes directly. You can whitelist the restricted push for specific users and teams. And if I come down, so I can also have some pull request approvals. So only if it, reaches this threshold, it's going to allow, merge the pull request with enough positive reviews. And we also have something called as enable status check. Okay, so if we enable the status check, so all the status checks should pass before merging. Okay, and you can see that it has a couple of checks by default. So this is added by Jenkins because we are using the plugin. So it's going to, you can add this as status checks. And if you enable this, I'm not enabling this. If you enable this, so these status checks should pass before merging. If this fail, you can't merge the pull request, right? So, you can, do these changes for additional security as well, but we are not going to do that for the time being. So let's go back to the pull request. So the pipeline should be completed. So let's go here. Yes, the pipeline has completed, and the K8's raise PR stage is also triggered and executed because this is on PR branch. So let's check the curl command. So you won't see much of a response here. So it's just going to give you a huge JSON file after the pull request. I'm not going to, go through this. So let's go to the manifest repository, which is the Solar System GitOps Aqua CD. And here, if I refresh, I should see a new pull request. Okay, so I should see new branch, which is feature-2, which just got created. And now, if you see the pull request, so there is a new pull request created 2 minutes ago. It was created by Git admin. and it is from the feature-2 branch to the main branch. Okay, so let's see here. So this was successfully created. It also has the body and the title which we used in the curl command within the Jenkins file. And you can simply merge the pull request because it only has one commit where, we are updating the image. Okay, so basically it just updates the, the commit ID. So let's go back and let's quickly merge this. So as soon as I click on merge this, so it's going to be merged to the main branch, and Argo CD should be picking up the changes. Okay, so currently if you see, it is picking the changes from the main branch of commit ID B6B. Okay, so this is one. So it should change to a new commit ID. Okay, so let's do that. Let me click on merge commit. I'll just go with the default values and create the merge commit. Okay, so this is successfully merged to the main branch now. So if I go to the main branch, so this got updated 3 minutes ago. Okay, so now, and if you see the commit ID, it is F590D5. Okay, so the same thing should be also seen here. So we need to do a hard refresh. So Argo CD default does a refresh every 3 minutes, I guess. So let me do a refresh. And yes, if you see here, now it found the updates from the new commit ID as well. So if I click on the Solar system, okay, it's not found on the cluster, but this is the manifest which it found from the main branch. So you can double check this. So let me copy this, go to Kubernetes deployment YAML, right? So if you see, this is the same deployment manifest file, which, which is pulled by Argo CD as well. So now let's go ahead and do the manual sync. So before I do the manual sync, let me go to my VM. So let's do a quick kubectl get all in the Solar system namespace. And if you see, we don't have anything over here. So now I'll go back to Argo CD and do a quick synchronization. So I'll just do synchronize. So it is going to create the deployment. It's going to create a replica set. And I think I've given 2 replicas. So it's going to create 2 replicas. It's also going to create a service for us. And it's also going to create a secret. So from the sealed secret, it's going to, create a secret for us as well. Okay. So even the pods are up and running successfully. If you see, there is a healthy heart icon available and the sync is also okay. Okay. So if I go back to the VM, and now if I do kubectl get all in the Solar system namespace, I should see 2 pods running, a service, a deployment, and a replica set. And these are just started 30 seconds ago. So let's go ahead and access this application on port 30,000. And the host name should be, one of this, pod names. Okay. So let's go back to the browser. Let me copy this endpoint and I'll just replace this with 30,000, which is the service node port for the application. Okay. Okay, I'm sorry. I think my ports are running on a, so this is Argo CD. Let me give it another try. Okay, so this is running on HTTP protocol, not HTTPS. So when I change this to HTTP, I should be able to, see my application accessible. And if you see, it also displays the pod name. Okay, so if I do number 3, or let's do number 5, so it should give me the Jupyter. So this proves that, it is able to connect with MongoDB by making use of the secret. And I also want to show you the secret as well. So you can see the secret either in Kubernetes using the kubectl command, or you can also check that in Argo CD, I guess. So if I go to Argo CD, I click on the secrets. Oh yeah, the secrets are not displayed in Argo CD UI for security purpose. So let's go to my Kubernetes cluster. So let me clear this. I do a quick kubectl get secrets. So there is a secret. Let's do MongoDB secrets. So let's do -YAML. So we got this secrets, and if you see, these are the base 64 encoded secrets. So we were making use of a sealed secret, but when the sealed secret was applied in the Kubernetes cluster, it made use of the Bitnami sealed secret controller to replace the encrypted values. Basically, it's going to decrypt them and create generic Kubernetes secrets. Okay, so this is how you can make use of GitOps. Automate the Kubernetes deployment by updating the image tags within a Git repository. And this is how you can automate the setup within Jenkins pipelines. That's all for now. Thank you. In this session, we're going to set up a couple of stages where we will be accepting a manual input from a user and also do a round of dynamic application security testing. So what is DAST? So dynamic application security testing is used to identify and address potential vulnerabilities before the application goes live. So the DAST tools can automatically scan the application's web interfaces and APIs to detect common vulnerabilities like SQL injections, cross-site scripting, and many others. So these tools rely on the running application instead of the source code. So when you compare DAST with static analysis doesn't require the application to be running. It depends on your source code. And DAST is quite opposite. It requires a running application so that it can inject malicious payloads to identify potential flaws, which allows the attacks. So what are the different tools which are available to do this DAST testing? So you have both open source and commercial tools. So we will be making use of the open source tool called as Z Attack Proxy. In short, it is called as ZAP. And then we also have commercial tools like NetSparker, Burbsuit, and others. So let's go ahead and use this open source ZAP tool, which is provided by OWASP performing security testing. So this is the web page for ZAP Proxy, and this is the most widely used open source dash tool, and it can be done in multiple ways. So let's check out the documentation. So again, as mentioned, you can use ZAP in various different ways. So we will be making use of the Docker approach. So we'll use the Docker images. So again, in the Docker images, you have different images for different scans. You can do 3 different scans if I'm not wrong. So you have the baseline scan, which is a time-limited scan which reports issues found passively. You have a full scan, which is going to use optional Ajax spiders, and active scan, which reports issues found actively and passively. And we have something called as API scan, which does a full scan of the API defined using either OpenAPI specification, GraphQL, and I think the older versions also supported SOAP as well. So this Docker images are an easy way to automate the ZAP process, especially within a CI/CD environment. So we will be making use of the API scan. Ideally speaking, our application has both APIs and also a front-end application. So you need to use a full scan, but just for the demo purpose, we'll only do the API scanning. So in API scanning, if you are selecting this, so you can do the scan against an API, which is defined using OpenAPI, SOAP, or GraphQL. So it can be given either using a URL or as a local file as well. Okay. So it also, It basically, includes two scripts, which, raises alerts for any HTTP server error response codes. And it also raises alerts for any URLs that, which return content types that are not usually associated with APIs. And if you want to know what are the different arguments which are supported by this, so you can just check a look at this usage. So this is the Python script which it uses. You have to give a target. So the target is nothing but the API definition. Okay. And you can also, select the format. Okay. So based on, I think we will be making use of Open API specification, but if you have GraphQL endpoints or so, you can also give it. And you can generate the reports in different formats. So these are the, different options. So let's go ahead and configure this within our Jenkins file. So if I go back, so in the Jenkins file, I've already copied a stage to save some time. So let me go through each and every line and explain how this works. So the name of the stage is dashed OWASP zap. And this is only going to be triggered on the PR branch for the pull request. So I'm using a when condition over here, and it has a step. So within the step, I'm using a shells, script over here. I'm using a Docker command, right? So I'm using Docker run. I'm also, doing a volume mount of the current working directory so that, it can copy the reports which are generated in this container to the current directory or the working directory. But you also need to provide some permissions. If you don't provide permissions, it cannot copy, the generated report. Again, it can be done in a couple of different ways. I'm just choosing this approach. So to give permissions, so I'm just using chmod 777 to the current working directory. Okay. And then the image for the ZAP or the ZA proxy is, I'm fetching it from, I think, GitHub container registry. And the Python script is something but the ZAP API scan. So we just want to do the API scan. And what are the arguments which I'm passing? So the target is nothing but our application. So this is the application which was just deployed to Kubernetes, and it has an endpoint/API docs, which basically gives the Swagger JSON file. And since I'm using Swagger or the Open API specification, the format should be -f Open API. And I want to generate the reports in HTML, Markdown format, JSON, and XML. So I'm just, giving all the different, output. Right. So after you do this, so before I commit, so let me just show you this API docs. So let's go back to the browser. So this is the application which we deployed in the previous demo. So there is an endpoint/API docs, right? So this basically gives you the Open API specification for this application. And the same, JSON is also available as part of the repository. So if you go to the repository, so it has a oas.json file. So this is the same Open API specification, which is used in this endpoint. Okay. So that is what we have, defined it over here. Okay. So before I commit, let me explain that, we require one more stage before you execute this. So if I scroll up, I am adding another stage called as app deployed ? What is the reason of having this stage before running the OWASP ZAP stage? So if you remember, ZAP or the dashed requires a running application, and we are, deploying the application using the GitOps approach. So in the GitOps approach, if I go back to the Jenkins pipeline, in the GitOps approach, so we are making use of, updating the Docker image tag using a Jenkins stage where we are, pulling or cloning the repository and manually updating the ID and, again, pushing back the changes. And we are raising a PR. So once the PR is raised, so there is a manual process. So a person has to, merge the PR or check the PR, validate it, merge the PR, and then the person has to also synchronize Argo CD. Once Argo CD is synchronized, then the application is deployed or the latest changes are deployed. So if you directly run the dynamic application security testing, this is going to run for the older versions and not for the latest versions. So before you run this stage, you need to have a manual approval in between where a user can confirm that, the pull request which was raised earlier has been validated, merged, and the Argo CD application is also synced. And then only, you want to trigger the OWASP. So to do that, we added a stage called as app deployed. Even this is going to trigger only for the pull request branches. And within the steps, I'm having a timeout. So the users will be having, 1 day time in order to either approve this or, stop the build. Okay. So that's the timeout which I'm using. So this can be in seconds, days, or even weeks or months, I guess. And then I'm using something called as input step. So how do I get this input step? So to get this input step, you can go to the pipeline syntax generator, go to declarative directive generator. Here you have this input option. If you want to know more about this, you can check the documentation. So the input directory is going to allow you to promote or to prompt for inputs using this step. So the stage will pause for any options having been applied, and it has to be either accepted or declined by user. And if no input is given by the user, so you can also use a timeout option to, stop the build or to just fail the build if there is no input. So you can give some message, and you can also have some advanced options. So you can have a custom ID, some text on the OK button. You can also allow to be only accepted by admins or specific users, and some parameters can also be stored. So I'm just going to say test 1, 2, 3, generate. So this is how the input is going to be generated. And the same thing I have, defined it here. So it has input message. So the message is the PR merged and Argo CD synced? And in the OK button, it's just going to display this message. Yes, PR is merged and Argo CD application is synced. Okay. So these are the changes which I have done. So I'm just going to quickly commit them. Okay. So let's quickly commit. So let's go back and see if a pipeline are triggered. So a new pipeline got triggered for this PR build. So let me just pause the video till this gets completed. Okay, so we are back to the Jenkins pipeline. And if you see here, the Jenkins pipeline is currently in pause state. So why is this happening? So if I scroll to the right side, you can see that it has successfully updated the image tag and also raised a PR. And now it is waiting for a manual input from the user. And this input, so whatever we have given in the Jenkins file, so it's going to just display it over here. So it's the PR merged and Argo CD synced. And in the OK button, so whatever text we provided here, right? So whatever text we gave in the OK button, so that is going to be displayed here. So you can either approve or abort. So if you abort, so the next stages will not be triggered. So if you say yes, and then the next stages will be triggered. And this is going to, be in this state for 1 full day because we have used a timeout option as well. Okay. So now I hope you understood why we required this stage. So we have to go and manually, merge this PR and sync the Argo CD application. So let me go back and quickly do this. Right, so a new pull request is available here. Let me merge it. Okay, so this is merged. If I go back here, and I'm sorry, I think I have to go back to Argo CD. I hope this is support. Yes, that's support. So if you come here, if I do refresh, so this will be out of sync because now it found new changes in the main branch. So I need to manually synchronize this. So let's do a manual synchronization. So it's going to deploy a new set of pods, and it's going to update, right? If you see, two new set of pods have been created, and the older replica seg pods will be terminated. So the same thing can also be checked here as well. So if I do a quick kubectl and solar system get pod, right? So two previous pods which were created 50 minutes ago are terminated, and two new pods are getting created. So this, completes the sync process. So since the manual process has been completed, so an admin or a user can come to the Jenkins pipeline, and he or she can quickly click on yes, ER is merged. If it is yes, then it's going to go ahead and execute the DAST zap stage. So now this stage is going to, make a call to the, Kubernetes endpoint, which has the latest application or the latest version of the application. If we didn't have this app deployed, this might, run the test for the older versions. Okay, so that's the reason of having this manual input in between. So let's give this stage a few seconds. It's going to, if you see, it's importing the URLs, and it's going to run the tests on this URLs. So let me pause the video till this gets completed. Okay, so if you see here, the DAST OASP zap stage has failed. So let's scroll and see what has happened in this stage. So if you scroll down, it's going to show you that it has run a lot of tests, and a lot of them have also passed. So you can, check out, all the stages or all the, tests which have been done. But if you come down, there were no failures, but it found a warning. So if you see, it found a warning of unexpected content type was written, and it found this one new warning. So total 112 tests were passed, but found one new warning. So because of this, the exit code was 2, and the stage was marked as failure. So this is how the dynamic application security testing works. So in the next session, we'll try to resolve this issue either by fixing it or by ignoring it using some ignore options. Thank you. In the previous session, when we executed the dynamic application security testing, it exited because of a few warnings. So in this session, we'll try to ignore those warnings. So if you see here, this stage logged one single warning, and the warning was of type unexpected content type. So ideally speaking, as a developer, you need to fix this issue so that there are no vulnerabilities for your application and to make it secure. But for the time being, since this is a training course and a demo, I just want to show you how to ignore the errors. So sometimes you can ignore some vulnerabilities or some test cases. So how to do that? So for doing that, we can rely on the documentation. So you need to create a new file or a config file. In the config file, you can use ignore tag for ignoring certain warnings. And you can pass the file to the Docker command using the -c option. And the config file, you can download the config file by making use of the -g, which is going to generate a file which contains the default config file, which contains all the rules. And this is how the file looks like. So it has the ID of the test, the warning, and the description of it. So we can change the warning to ignore the rule, or fail to fail if the rule matches. Okay. So we will be following this format. So it needs to be the ID of the rule, a single tab. You need to give ignore, a single tab, and the endpoint as well. So let's try to create this file and configure it in our Jenkins file. So back in my virtual machine, So let's create a new file and the repository. So the name of the file is zap ignore rules. Okay. So here you need to pass in the ID. So first, let me configure this. So let's configure the file which we just created. So within this stage, after generating the XML report, and just add -c, and I'll just paste the name of the file, zap underscore ignore underscore rules. Okay, so let me save this. So let's go back to our previous Jenkins build, and we need to copy the value. Okay, so the ID. Let's come back. So let's paste the ID. I'm using a single tab. I'll say ignore. I'm using another single tab, and I need to provide the endpoint. So let me just copy the endpoint over here and paste it. So you can give a list of IDs which you want to either ignore, fail, or raise a warning, and you can save them in this file. So once you save them, I guess I just reference the file here as well. So the other thing which I want to do here is, so this is also going to generate a HTML report. So we'll publish the HTML report using the publish HTML option. So I'll go to post always. Let me just paste in the HTML thing. Let me just do a word wrap. So here I'm using the publish HTML step, where it is going to find the HTML page in the root directory. The name of the file is zap underscore report.html, and the report name would be DAST zap report. Okay, so that's how I'm going to publish the HTML report. So these are the two changes which should be enough, but let me do a small cosmetic change in the front-end application. So if you remember the front-end application, so if you see here, it has a rocket in between Solar system. So I just want to add a couple of more rockets just to, give you a visual view of updating the changes. So let me go back. So I'll go to index.html page. So here on line 66, so this is the line which, displays the solar system with the rocket in between it. So I'll just select this rocket code, and I'll just add it before solar and add it after the system as well. Okay, so let's see how it looks in the UI. So these are the changes which I wanted to do. So let's go back. Added zap ignore rules and modified front end. Okay, so these are the changes which I'm doing. So I made 3 file changes. So let's quickly commit them and push. So let's go to the Jenkins UI. A new build should be triggered. So let's go to pull request. Yes, a new build got triggered. So I'll pause the video till it comes to the input stage. Okay, so if you see here, the build has paused on the app deployed stage. So before I click on yes, so let's go ahead and merge the changes quickly to the GitOps manifest repository, merge the pull request quickly. Okay, this is merged. Let's go to Argo CD. Let's do a quick refresh. So this will be out of sync. So before I synchronize this, so let me just refresh this page and show you that, the UI still only has a single rocket displayed here. Hopefully it gives me, 3 rockets. So let's do a synchronize. Okay, so it should come up with 2 new pods. and a new, replica set as well. So if you see there's a new replica set, one pod is up and running, the other pod is still coming up. So that's it. So the previous pods are getting terminated and two new pods, are spun up. So let's check the updates. Okay. So let me quickly do a quick refresh. So I don't see any major changes over here. Yep. So once I refresh this, so if you see now the UI displays three different rockets. I mean, three rockets instead of one. So the changes are reflecting correctly as per our pipeline. So I guess all the things are, doing good. So I'll go back to the Jenkins pipeline and I'll say, yes, the PR is merged and the application is synced. Everything is looking fine. Okay. And it resulted in an error. Let me see, what is this error? Okay, I think it is having some issue with the ignore file. Okay, so let's see, unexpected number of tokens on the line. There should be at least 3. Okay, so I think I know why I'm getting this error. So let me go back to my virtual machine. I think I have manually created this file using the Visual Studio Code Editor, which is basically the Zap ignore rules. So let me try to create this, using the VI editor. So let me quickly go to Solar System. And here, I think I need to use VI editor. And here, let me, okay, so I removed them. So I'll use a single tab. Okay, so I guess this should work, a single tab using the VI editor. Hopefully, let me commit this. Let's commit and push. So a new pipeline should be triggered. So I'm going to pause the video till, it comes to the, let me go to the PR stage. Okay. So I'm going to pause the video, but this time I'm going to also, do the merges, do the Argo CD sync, and then I'll quickly, approve the input stage and, check out the dash stage. Okay, so I'm again at the input stage. So I've already, synchronized Argo CD and did the merge as well. So let's go back to Jenkins, click on yes, PR is merged. I hope there are no issues this time. So the Docker command is running successfully. So let's pause the video till this gets completed again. Okay, so finally, the Jenkins build has been completed. So even the dynamic application security testing stage is successfully done. So let's check out the logs. So if I check out the logs, so again, it is going to, give you the warning, but now the warning is ignored. So since the warning is ignored, you don't see any exit code. So you can see pass is 112 and ignored is 1. Okay. So this is how you can do OS Zap testing. You can ignore certain vulnerabilities or issues as and when required. And it also generates, HTML report. So let's check the report. So we should be having DAST OS Zap report. So let me open this. So again, CSS is missing, but I hope that's fine. So it found the number of alerts is, I think it found one low risk level and 2 informational risk level alerts. This is the summary of alerts. And so the number of instances. So, it gives a lot of data over here. So this is again a very huge file. So with CSS enabled, this would be pretty using the HTML and CSS. But I hope you know how to enable that using the content security policies. So I won't be doing it again. So this is how, we can deploy the application to Kubernetes, have a manual input stage, and then, do a round of dynamic application security testing. So before I close this session, I just want to give you a small update. So ideally speaking, this feature branch should only be used for enabling the Jenkins CI/CD pipeline. So we should not be doing any code changes like, adding, I think we just modified the code by adding a couple of sockets. So if you want to modify the code, it should be done on a different feature branch, because for any code changes, it should also go through the AWS deployments, right? It should first go through the AWS deployments on the feature branch. If everything is passing over there, then it should come to the Kubernetes deployment when a pull request is raised. And if this stage is also successful, then it should go to the main stage. Okay, but in this scenario, I just modified the application code just for the demo purpose. I hope you understood everything up till now. So in the upcoming stages, we are going to merge the pull request and then create a couple of stages for deploying the application to AWS Lambda. So that's all for now. Thank you. So far, our pipeline has generated various reports, and in this session, we will upload all these reports to an Amazon S3 bucket using the Jenkins pipeline. So if I go back to the Jenkins pipeline, so this was the latest build. And if I want to show you the files which we want to upload, so I can go to the classic Jenkins UI, scroll down, go to the workspaces, and so these are the different files I have in my workspace. So we need to upload the coverage report. So the coverage report is part of the coverage folder. So it has different files within it. Apart from that, if I scroll down, so we have a lot other files as well. So let me quickly highlight them. So if you see this, so we have reports with respect to dependency check. So we have them in different formats. We have the unit test report, which is test-results.xml. Then we have the Trivy reports, which are generated when we do the vulnerability scanning. And the latest reports are of ZAP. So these are the dynamic application security testing reports. So we would like to upload all these reports to Amazon S3 bucket. So we'll see how we can connect with an Amazon S3 bucket and upload this. So for doing that, so the first thing what we need to have is an S3 bucket. So within my AWS account, if I go to S3, I have created a new bucket. So the name of the bucket is Solar System Jenkins Reports bucket. So this is within the US East 2 region. And if you see, the bucket is empty for the time being. It does not have any objects or any entries. And for connecting and doing the uploading, of course, you need to have, you need to be authenticated, or Jenkins need to be authenticated. So I have created a user. I think we have already seen this in one of our earlier sessions. So let me cover it quickly. So I have a user. The name of the user is Jenkins user. And this user has permissions for, working with Amazon EC2, Lambda, and also S3 as well. So if you see, it has full access to Amazon S3. Okay, so it can do, all the actions. So this credentials, I've also securely stored them in Jenkins using the credentials option. So I can also show that quickly. So if I go to manage Jenkins, credentials. So if you see here, I have this AWS S3 EC2 Lambda creds, which contains the credentials which are used for connecting and working with S3 buckets as well. Okay. So the next step is, how do I connect with this S3 bucket and publish the reports using Jenkins? And I think we have also covered this. So if you remember, we installed a plugin called as Pipeline AWS Steps using the Jenkins plugins option. So this is already installed on my Jenkins controller. And if you see the documentation, so one of the option is S3 upload. You can also do download, copy, delete, find files, pre-send the URLs and some other actions as well. So one of the option is the S3 upload. So you can upload a file or a folder from the workspace. And the bare minimum required arguments is you need to, have the file name, you need to mention the bucket name, and you also need to, mention the path, like what would be the path in the S3 bucket if you want to have it as a separate folder. So how do we do this? So before I make use of this S3 thing, so let us try to copy only the relevant files, because in our workspace, we have a lot of files. So let me go back to my workspace. Okay, so if you see, we have a lot of files and we have, multiple reports, right? So how do I identify the files which I need to upload? So for doing that, I will be creating a new stage. So let me go back to my Jenkins file. So in my Jenkins file, so the last stage which we created was the DAST OWASP SAP stage. So after this stage, I have added another stage. The name of the stage is upload AWS S3. And this stage will also trigger only for the PR branches. Okay, so I added a when condition. And within the steps, I have a single shell script. So this shell script is going to prepare a directory with all the reports which I want to upload to S3. So first, just for the demo purpose, I'm doing a list of all the files. And then I'm creating a new directory. The name of the directory is reports-$build ID. So for each build ID, it's going to create a separate directory. And I'm just using the copy command. I'm copying everything from the coverage folder to the directory which I created in the previous command. And then I'm using another copy command to copy a dependency. Hashtag, I'm just using a regular expression because we have multiple files. So I'm, copying everything from dependency, which I started with dependency, testresult.xml, Privy, ZAP, right? So all the files which, matches this regex patterns will be copied to the reports directory, which I've created earlier. And then I'm just listing the directory again. Okay, so this is the step where I'm just preparing the directory which contains all the reports which needs to be uploaded. So what is the next step? The next step is using the S3 upload step for uploading this specific, file. So how do I do that? So for doing that, I can go back. So I can use this format itself. So I can, directly copy this and paste it in my Jenkins file. Or if you want to, get this and also, work with other options which are available in the S3 upload, you can go to the snippet generator. In the snippet generator, just search for S3. So there should be something called as S3 upload, copy files to S3. And here, if you see, it has a ton of arguments which can be used while you're uploading to the S3. Okay, so we won't be using all these options. It might be relevant for others who need few other, arguments enabled. Okay, so for us, we will be working with the file, bucket, and the path. But if you also want to exclude some patterns, include patterns, add metadata, or use cache control, or also use access control list, right? So you can select all these arguments here, and it's going to generate a step for you which can be directly copy pasted in the Jenkins file. Okay, so for the time being, I'm not going to use this. So our use case is a bit simpler compared to this. So I'm just going to copy this from the documentation, S3 upload. I'm only interested to use these three arguments: file, bucket, and the path. Okay, so let's go back to the Jenkins file. So after the shell script, so I'm just going to copy paste the S3 upload command. So let me just add this in a new line. Okay, so what would be the name of the file? So the name of the file in our case would be reports file. Okay, so let me just add reports. So what would be the path? So I would like to add this to a path within the S3 bucket. It's going to be added to a path called as Jenkins-build ID. Okay, and then the bucket. So what is the name of the bucket which I want to use? So again, I'll go back to my S3. Let me just go to my S3 bucket. Okay, so let me just copy the name of this. Okay, so these are the three options which I provided here. But before I save this, I need to do one more change. So the change here is, so here if you see, I'm using a key and a value, and in the value, I'm having this dollar value. So basically this is an environment variable, right? So in order to replace this, if I use single quotes, it will not work. I need to use double quotes. Okay, so let me just use double quotes. So this is because of Groovy scripting. So similarly, I need to change it in the path as well, because even in the path, we are making use of a environment variable. So you need to do the string interpolation. So if you want to know more about this, we can go back to the documentation. So there is something called as string interpolation documentation within Jenkins, which basically says that, the pipeline uses a Groovy string interpolation. And if you see here, you can, define a string using, you can create a variable or define a string using a def username is equal to something, or it could be an environment variable. And if you want to use this variable within your Jenkins file, if you use single quotes, it won't do the replacement or it won't do the substitution. You need to, enclose this in double quotes. So then only it's going to support the dollar sign or the variable. So that's how the string interpolation happens. So whenever you're using the dollar sign to replace the variables, so make sure you enclose them in double quotes. Okay, so that's what I have done here, right? And the last step before I commit the changes is that in order to connect with S3 bucket, it needs to authenticate. So how do I authenticate to S3? So I think I've already done this earlier. So let me just scroll up and copy paste it. So within the integration testing stage, we were trying to make use of the AWS CLI for fetching the IP address of the EC2 instance where we needed to authenticate. So we used the with AWS step where you can pass in the credentials as well as the region. So let me just copy this. So this is the same thing which we have to do for the S3 bucket as well. And the credentials won't change because I'm using the same set of credentials which has permissions for S3, EC2, and Lambda. So let me just copy this, scroll down to the steps. So here, I think we need to close this properly. That's it. Okay, so if you are unsure like how this is generated, so we can go back to the snippet generator. So in the snippet generator, you can just search for with AWS, and with AWS, you can give a region value. If you are connecting with some, mock AWS instance, you can give the endpoint. You can also give the credentials. So if you don't have the credentials, you can add the credentials. And when you click on generate snippet, that's how you are going to, get the with AWS snippet. Okay. So that's the same thing which I've done here. Instead of generating it, I just copy pasted it from one of the previous stages. Okay. So after you do this, I think we are ready to commit the changes. So let me quickly check this out. I'll just add a slash here. Okay. So let's go ahead, save and commit the changes. So let's commit to the feature branch. So let me go back. So a new build has been triggered. So let's pause the video till it comes to the app deployed stage. Okay, so as you can see here, all the stages have been successfully completed. So a PR was raised. I have accepted, merged the PR, and then I've also synced the Argo CD application before I, unpause the video. And then it completed the OWASP ZAP stage successfully. And it also triggered and successfully completed the AWS S3 upload stage. So if you see the logs of this stage, so first it's simply going to list out all the files in this workspace. So you can see it has various different reports and files. And then we created a directory with the name reports hyphen the build ID. So the build ID is 6. So you say reports hyphen 6. It's going to copy the coverage, and here we made use of some regex patterns. So it is uploading, all the reports which matches those regex patterns into this directory. And after this, I'm just listing out this directory which contains all the reports. Okay. And then the next command is of copy to S3. As you can see here, it is uploading the reports -6 directory to the AWS S3 bucket. And within this bucket, it is creating a new directory or a path. And within this path, it's going to, upload all the reports which it finds in the reports -6 path. Okay. So after this is done, we can also verify this. We can go back to our Amazon S3 page. So let's go to this and let me refresh. I think I need to refresh this. I should be seeing a new object, Jenkins -6. And within this, I should be able to see all the reports. So we can also open the reports. I think, let me just open one report. Let me open the latest ZAP report HTML. And let me open this in browser. Let's see how it looks, right? So you can see that it we can also, quickly check out the report using the browser as well. Okay. So this is how you can quickly add a stage, connect with Amazon S3 and upload files to the S3 bucket. And to do that, we made use of the pipeline AWS steps plugin, where we have the S3 upload step. And then in order to authenticate, we are using the with AWS credentials and the region, step over here. So that's all for now. Thank you. Okay, so let's go ahead and deploy our application to production. So what are we going to do in this